Okay, so let me read. Things to label when you are sketching a graph. Number 0 is automatic. Nobody needs to tell you. I think you should already know this. X, Y axis and origin. Okay. Number 1, is where I want to start. Equation of the function. Every time you draw a sketch of the curve, you need to draw the equation of the function. Okay. Here, all the questions you never label the equation until later on when you start rational functions, then you start to label. So not sure why. Please remember to label. Number 2, intercepts. You must find your x and y intercepts, meaning you can sub y equal to 0, then you solve for x, or sub x equal to 0, solve for y. Okay. Then there are a few ways to label intercepts. Like for example, if you have a quadratic equation, let's say this is y equal to x squared, I don't know, minus 10 or something. Then here the two roots will be negative square root 10, positive square root 10. Here's one way you could label the x-intercepts, and here is a negative 10. Alternatively, you could also label it as coordinates. So this will require a bit more space. Let me zoom in. You have negative square root 10, 0, positive square root 10, 0. Or over here, it's 0, negative 10. Y-axis, x-axis, origin, label equation of the graph. Origin, label equation. Okay, can? Can, yeah, so label that, and turning points. You must make sure you label turning points. In this case, my turning point happens to be 0, negative 10. Then point of intersections means that POI means point of intersection of between graphs. When two graphs intersect, you try to label the coordinates of the point of intersection. Anything else? Right, yes, asymptotes. Yes, quite important, very important. Horizontal, meaning left, right. Or oblique, meaning slanted. This way or this way. Diagonal, huh? Horizontal will have the form of y equals k. Oblique will be y equal mx plus c. Straight line. Okay?
Okay.
Can, oh, one more, vertical, of course. That's up and down. X equals to some, sorry, x equals some constant. I'll just call it k. It's not related. K1, this one K2. Okay, they are different constants. Okay, can? Okay, good. So let me just state a few problems with your question 1 first. Here forget to label, here forget to label, but the rest is fine. Also here 1.67, 7.63. Here's that is the GC value given by the GC, right? 3SF. That's fine. It's okay. But take note that sometimes in future, the questions will require you to find the turning point in the exact value because they're asking you to solve for an unknown A or something. So I hope you remember, like sometimes but this is fine, this is okay. Sometimes if you see 1.66666, please know that this is just 1 2/3. Those kind of standard recurring decimals, or 0.333 recurring is the same as 1/3. Or 1/9 is the same as 0.1111 recurring. I think so, if I'm not wrong. Do you know why? Do you know why they are the same?
No.
Okay, very quick explanation. I'll let x equals to 0.1 recurring with a dot on top. That means that this is 0.1111 many times. If I just take 10x, here I make a clever choice, I multiply by 10. What happens to your decimal? Move 1 time. So you're left with 1.1111. An army of 1 that never ends. Okay, what happens if you take big minus small? You're left with 9x. But if you look carefully, you're taking this guy minus that guy. What are you left with? This is 2, this is 1. What you're doing is 2 minus 1, which means you're left with
1.
Just a 1 only, right? Then 9x equals to 1. How do you solve for x? 1 over 9. That's how you get the answer. So let's say this is recurring decimals, right? Right? No? Yes? No?
Yeah.
Okay, then just note on recurring decimals, the notation is that like for example, if you have 0.102, maybe I put on 0.123, then 567, 567, 567. All the initial start 1, 2, 3, nothing happens, but only the 567 keeps on repeating. Then the way to write it is 0.123, 567 with a line on top. Alternatively, dot on the 5, dot on the 7. Okay?
Oh, okay.
Okay, good to know only. How to convert this into a fraction? You just have to do some trick. Maybe I'll do a quick one for this one. Let's say x equals to this guy. Then in that case, you can just multiply such that multiply by a multiple of 10 such that the decimal is just before the repetition. So in this case, I see I need to multiply by 1,000. So 1,000x in this case will be 123.567 recurring. Then in that case, I'm gonna, okay, maybe I don't write the recurring. I'll just write 567, 567, dot, dot, dot. Then if I multiply by another copy of 1,000, so it's now 1 million x, I end up with 123.567.567. This is not a very nice way to write it, so I will purposely rewrite it in the following way. Let me adjust until it looks like this. Can you see what I just did? I purposely align the decimals. Okay? What happens now? What do you notice after the decimals? They are both exactly the same, right?
Yeah.
So we're going to take big minus small. 1 million minus 1,000. That's 999. No, 9,000. 999,000 x. Correct or not? Big minus small. Big minus small. What are you left with? The decimal will cancel with the decimal. Whole minus the whole. So 1, 2, 3, 5, 6, 7. Subtract away 1, 2, 3. You're left with 1, 2, 3, 4, 4, 4. Is that clear?
Yeah.
Can, right? Then therefore x equals to 1, 2, 3, 4, 4, 4 divided by 999,000. Okay? Then you can type in a calculator to convince yourself you will get whatever value, 0.123,567,567,567. Recurring. Okay?
Yeah.
Okay, yeah, so that is how you obtain recurring decimals. Anyways, that was just a side. Let's move on to the main topic. Okay, now 2A, how to do this question. So again, can I request for you to don't be you can hug the trees after A levels. This one also digital paper, right? I recommend you.
These are all my paper.
Sorry,
These
paper.
are all physical paper.
Okay, yeah. You can hug the tree after A levels. This one try to split it up so that I can add a new page. Okay. Okay, it's good to save the environment. Sorry, but yeah. Okay, I'm just gonna add a new page. Anyways, let's see. Question 2A. How to deal with this? First thing you must remember is the tree. Okay. Crash course revision on how to draw the conic sections. Is that okay?
Yeah.
Question 2A. Crash course revision on conic sections. So there are 3 types of conic sections. Okay, conic sections are essentially just a double nipped cone, like this. And then you can imagine drawing a few different types of planes. If you can imagine, let's say this is a plane that cuts across it. What shape do you get over here? You realize that it will intersect as a circle if it is parallel to the cone. Here is a cone, there is also a cone, but connected at the top. They are perpendicular, like an hourglass. Then now if the plane is parallel, okay, it's parallel to parallel, it's supposed to be 3D, parallel to the slant height of the cone, right? What will you end up with? What you'll end up with is a shape that looks something like this part here. Can you see the dotted line?
Yeah.
That's actually a
Hyperbola.
no, parabola. This is quadratic curve. Okay, quadratic curve. This one, circle is circle. Then when do you get actually no, sorry. Am I confusing it? Actually, yes, you're correct. No, this one is hyperbola. Yes, you're correct. This is hyperbola. And it's parallel. Oh my goodness. Hyperbola. Something like this. Is it right? Wait. No, I'm correct.
Oh.
Yes, I'm correct. The first case. Yes, this is a parabola. Hyperbola is the case where you have a vertical intersection like this. Okay, so it will intersect 2 times, right? Can you see?
Yeah.
Go up and then go down, go down and then go up. Okay, so you have this. Oops, let me highlight it. This curve and this curve. Then that's how you get a hyperbola, right?
Yeah.
Okay. Hyperbola. Yes. Okay. Right. Okay, so that is the 3 shapes you need to know. But let me just draw a sketch. So like this. X, y-axis, x-axis. Parabola is something like this. Quadratic curve, you know how to do that. Hyperbola, a bit more sophisticated. You have to consider like asymptote, the oblique asymptote, and then you either draw a x, turning point here and there. Take note that the asymptotes are not always passing through the origin. It doesn't always pass through the origin. Also, your drawing, you draw 2 lines for me. Wow, this one, it's not very nice. Try to make it into tinier splitted lines. So that it's clearer. Because I was quite confused by it. How come suddenly got diagonal line? Oh wait, it's an asymptote, right? Bit confusing. Alternatively, could have also vertical. So for example, like this, and like this. Okay, so 2 turning points. Okay, so now how to sketch? Before I even proceed, can I recap with you completing the square? Do you remember how to complete the square?
I think so.
X squared plus, I'll give you an even number, 8x minus 11. Complete the square for me. So what do? Okay, I recap. You see x, you bring down x. You see plus, you bring down plus. Open bracket, close bracket, before the square. You see the 8, what do? You take 8, you divide by 2. This is called half the coefficient of x. Half the coefficient. Half coef of x. Then the square goes outside the bracket. You subtract away the exact same number. Bracket square. Then don't forget something is missing. What's missing? What's missing?
The 11, the minus
11. Okay, then you're done. So complete the square, simplify 8 over 2 is 4. That's why I purposely give a even number here, so it's easier to divide by 2. Usually it's not that nice. Usually it's an odd number. Then you're gonna have a very painful time. 7 over 2, that kind of thing. Minus, this one is just use a calculator. Minus, but let me just do it mentally. This is minus 27. Okay, completing the square done. What's so special about this format? Straight away you can find one particular point that this quadratic curve passes through. What's that point? The turning point, TP, not toilet paper. Turning point. What does it stand for? What is the turning point?
The maximum or minimum point.
What's the coordinates? In this case, it's a happy phase, right? Because there's a positive coefficient. So of course it's a minimum point. So what's the coordinate?
-4, -27.
Well done, very good. You're supposed to take the expression inside the bracket equate to 0, bring the 4 over -4. Okay, that is when you're dealing with x. Can we do something similar when now we have a mixture of x and y's? Let's say for example, x squared plus 2x, and then plus y squared plus 6x. Maybe I don't put y equals, I put equals to -1. Can you do something similar? Yes, let me show you. So basically this part here, A, can complete the square. Don't care about what the constant is. Whatever is the constant, don't care. Just focus on the x squared, the quadratic, and the linear. Factorize, you get, complete the square, you get this guy. Is that okay?
Yeah.
Then how about the y squared plus 6x? Can you try? Open bracket. Try.
I see.
Say,
y plus 6/2 square.
Close bracket. Square.
Minus the 6/2 bracket square.
Good. Equals -1. Can? Then so on and so forth, you can clean up. Okay, clear? So you must make sure you see x squared, you see a x, then you can factorize. You see a y squared. Oh, sorry, this should be a y. I meant to write a y. Pretend you didn't see the x. Y squared plus 6y is supposed to be this format. Sorry, this entire format. Maybe I'll change the purple highlighting. Okay, so that was a quick recap on completing the square. Okay, good. So now every time you need to identify, you need to know completing a square. Now we move on to the three shapes. So let me write down the table for you. Table. This is to identify equation of conic section straight away. How do you know straight away? This one is conic section, not rational function or anything. So what you need to do is to identify step 0. Step 0, you must see x squared or y squared. Okay, somehow you must see x squared or y squared.
Oh, okay.
It can be only x squared but no y squared. Actually, no. Only x squared, no y squared. That will probably be a quadratic. Only y squared and no x squared. That's a bit funny. Okay. The case is when you have y squared equal to x, no x squared. What is this curve? This is not a function anymore because if you make y the subject, you get plus minus square root x. How to draw square root x? Is it an ellipse?
No.
No, it's this guy or that guy. This guy is positive square root x. That guy is negative square root x. Okay. Please take note of that. This is square root. Let's just exclude that case. So you see x squared, you see y squared, you'll get a conic section. What else? More specifically, a table. Look at the coefficients. Pay attention to the coefficients and the sign. Maybe the magnitude of the coefficient. Absolute value means magnitude. So we only care about the value. So let me just give you some examples of equation of the three shapes. For circle, okay, this one is examples. It's x squared plus y squared equal to 1. For ellipse, right, I forgot to mention ellipse. One more. Where do I get an ellipse? How do I obtain an ellipse from a conic section?
The circle?
Yes. Ellipse conic section. Let me just search this. Now, right. Oh, you have to cut it at an angle that is not parallel. This one is parallel to the slant height. Let me just shrink down my diagram and include one more. Okay, the last scenario is when your plane that is cutting it is a bit slanted. See, these guys are not parallel. And you have this plane here that intersects the cone. You will cut it at a circular shape here. That will be the ellipse. Okay, maybe my diagram not so not so convincing, but you can Google it.
Oh.
Circle, ellipse, this one is parabola, that one, last one is hyperbola. Yeah. Anyways, we don't focus so much on the geometry, focus more on the math. Maybe I'll draw one more example of an ellipse, like a flat donut. Oh, chicken egg. Okay, something like that. Not so nice, but okay, you get the idea.
Yeah.
Okay, can, good. Now, let me just shrink my drawing down. Okay, back to the math, Okay, now we are focusing on an example for ellipse over here on the right corner. What happens is that sometimes you'll see 3x squared, and after that you see a 2y squared, or maybe just 1y squared equals to 1. You realize the coefficients of x squared and y squared, what's so special? They are?
The
You
same.
don't even need 1, it can be 4 as well. No, 3 and 1 here. They are? Same or different? Different, right? 3 and 1. Ellipse has a coefficients which are different. What else? This is plus sign, this is plus sign. So they both have the same sign. Okay? Let's try another example. This one is hyperbola. Should I go to hyperbola? Yeah, I'll just go to hyperbola. Ignore the quadratic. Quadratic too simple already. You already learned before in secondary school, right? Let's focus on the H2 math one. Hyperbola here in this case will be a bit different. I'll still put 3x squared. I'll still put y squared this time. So 1y squared. But this time I put a minus in between, and then I put some number, let's say, I don't know, 4 doesn't matter. What's so special? How do you identify it's a hyperbola straight away? Pay attention. There's a minus here. One of them is a 3 and 1. What's so special? They are different. What else about the sign? It's a minus. Actually, must we have the absolute value of the coefficients? So this 3 and 1 to be different to get hyperbola?
No.
Is 3x squared minus 3y squared, is this a hyperbola?
Yes.
Yes, you can divide by 3 on both sides, and then you get 1x squared minus 1y squared equals to 1. So yes, so no, you don't need the coefficients to be the same. So now we worked out a special rule already, right? Let's just summarize what our findings. Circle, ellipse, hyperbola. You can draw up a table. Focus on the absolute value of the coefficients. Then I'll put down same question mark. Yeah, so then inside the table, you just need to put yes or no, yes or no. I'll put tick to mean yes and cross to mean no. Tick means yes, cross means no. All right, so coefficient, absolute value of the coefficients of x squared and y squared each. So question, is it the same for circle?
Yes.
1. Yes, so put a tick. Ellipse?
No.
No. Hyperbola?
Also no.
Okay, actually this one is either. Let's just put a no to make the pattern easier. So basically, you need to see that for circle, you must have the coefficients to be the same. For ellipse, it is never the same. For hyperbola, it's maybe yes, maybe no. It's either. So how do you identify a circle straight away? You just look at this column. Make sure the coefficients are the same, and you get a circle of x squared and y squared. Step 0 is to make sure you got x squared and y squared first. Then the next one will be to look at the sign. Same or not? Tick means same, cross means different. So in this case, circle plus and plus. So it's same or different? Tick or cross?
Same.
Same, put a tick. Ellipse,
Same.
plus and plus, so same. Hyperbola?
No, it's different.
Must be different. Okay, I'll just put an eraser. So how do we identify ellipse? You just need to make sure you got coefficient difference, sign is the same. How to identify hyperbola? Well, we can't really look at the sign. So we can't focus on the modulus of the coefficients. So instead, we focus on the sign. You see, this is the odd one out, tick, and cross. The only one that's a cross is hyperbola. Right? So we must understand this straight away when I give you equation, you must tell me which one is it, circle, ellipse, hyperbola. Instantaneous, a few seconds. Okay, a bit like your indicator test. Don't know what. I also forget. What's it? This H or what's this alkene or something. I'm not sure what's going on. Then suddenly the H replaced with a huge compound here. I don't know what's going on. All your indicator tests also need to memorize, right? Math also need to memorize. Okay, can yeah. Okay, moving on. Let's try some extra practice questions before I get into it. So let's say we have example equation of a circle 3x squared plus 9y squared equals to 3. Wait, let me think of a good number. Let's say I times 2 to it equals to 2. What do you do? Make sure the right hand side is
1.
So you divide by 2 and then you end up with 3x squared plus 9y squared equals to 1. I'm skipping a few steps. Is this clear to you?
Yeah.
Good. Once it's 1 already, can we just conclude? Oh, so it must be 3, 9 as the center and the radius is 1, is it?
No.
Wrong. You need to do what? Complete the
Square.
Square. Okay, good. So complete the square. Actually, there's no x term. So it's actually done, right?
Yeah.
Actually done. Yeah. So sorry, this one is not circle. This one I just realized is an ellipse. It's not circle. Why?
Because the coefficient is not the same.
Very good. Okay, so now in this case, then what does it mean? Oh, not center, not center. So this is wrong. Radius is not correct. There's I like to call the x radius and the y radius. So does it mean it's just 3 and 9?
No.
So that means you have maybe, I don't know, center, don't know, then just put at 0. So +3, -3, then +9, -9.
No.
You draw. Is it that simple? No. So try to make it symmetrical. So no, of course not. What you need to do instead is to do the following. You have to rewrite it such that it is in the format of 1x squared over monster square plus 1y squared divided by monster square. These two question marks are not related. Okay, that's your goal. Equals 1. Then if you have the question mark underneath, that is your x radius and the y radius. This is what I call the x radius here. It's like a radius of a circle, but it's like x and y. Right? An ellipse is just a stretched circle. So that the r is no longer constant. Stretched circle. Yeah. How do you go from this to this? Very simple. You just need to realize that x squared times 3 is the same as divide by 1/3. Correct or not?
Yeah.
Take a while to process this. X squared divide by 1/3 means x squared divide by 1/3. Keep change, flip. Keep x squared, change, divide to times, flip the 1/3 to 3/1. You end up with 3x squared. Clear?
Yeah.
Now same thing with the y square. You can also bring the 9 down. So it becomes 1/9. Clear?
Yeah.
So x radius is 1/3 and y radius is 1/9, correct?
Like square root.
Very good. Wrong. Very good. You must tell me it's wrong. Then I know you understand. Confidently tell me it's wrong. No, this should be square root of 1/3. Square root of 1/9, right? You need to square root bracket square. Square root bracket square. Of course, usually it will be quite ugly, but in this case, yeah, it's quite ugly. Sorry. Okay, yeah. So anyway, square root 1/3, square root 1/9. That means that your graph should change from. I'm just gonna copy and paste this, but let me think. Let me just calculate the decimal value. I'm not so sure. Square root of 1/3. Is 0.577. This one is approximately square root 1/9, which is 1/3, which is 0.333. Okay, so who is bigger, who is smaller? X is bigger, Y is smaller. So that means, can I use this shape?
Cannot.
Cannot, so I have to, cannot salvage, never mind, redraw. X axis here, Y axis there. Oh, you try to make it straight. y-axis that origin. Well, we want 0.3 and 0.5. Okay, 0.5 here, 0.3 there. And just connect the dots with a curve, smooth curve that is symmetrical. Here is the, I will put the exact value as much as I can now. X radius, then the Y radius, positive and negative. How come I know the center is 0, 0?
It's like the x minus 0 square.
Very good. Yes, over here, there is actually a x minus 0 square over square root 1/3 square plus y minus 0 square over square root 1/9 square equals to 1. Now, the reason why I didn't have to have a change in the center, it's always 0, 0, is because at the first step, there is no linear term, no x or no y. Let's try an example now with x and y, so the center will move. So let's just do the same example again. So 6x squared plus, I don't know, let's say 6x plus 18y squared, I don't know, 10y equals to 2. What shape is this? Step 0, see, you got x squared, got y squared, so must be conic section. Then you look at coefficients, 6 and 18. Both are plus sign. Can this be hyperbola if it's plus?
Cannot.
Cannot. So usually, if the constant is a positive sign. Sometimes if it's a negative, you need to multiply by -1 on both sides. Then the story may be a bit different. But usually, don't need to worry. Plus sign means it's not hyperbola. So it's either circle or ellipse. Then 6 and 18 is different. Therefore, it cannot be circle anymore. It's an ellipse. Right. So what do? Usually they won't present to you so nicely. They will purposely swap it around to make your life difficult. Then sometimes they'll even factorize it just like the part A. Instead of 6x squared, okay, I show you. This is 6x squared plus 6x, right? So you can always factorize out the x, then or 6x, and then you're left with x plus 1, right?
Yeah.
Does it look familiar now?
Oh, so I was supposed to expand it?
Yeah, correct.
Oh. Okay.
Yeah. Once I go through this example, I think the solution don't need to go through already. Okay, so I'll just go through fully how to do this. Then maybe you can retry the question. I don't want to go through the tutorial because you got solution already. Okay, 6x squared plus 10y. First thing you need to do is identify your x and x. Then you realize you also got y and y. Oh wait, but this is equal to 2. So we need to force this to be a what? Force this to be a 1. So divide throughout by 2. Okay, and we end up with 3. I'll just erase it and replace 3, 5, 9, 3, 1. Clear?
Yeah.
Now, this guy and this guy, what can we do?
Like group together.
When you complete the square, sorry, I forgot to, my example just now was too simple. First step you need to do is to make sure the coefficient of x squared is
1.
1 by factorizing out, right? So factor out first, then you get x squared plus 3. Okay, next one, 9y squared plus 5y. You just factorize first. What do you want to factorize out?
The 9.
The 9. So unfortunately, it gets quite ugly now. 5 over 9y. Sorry, I didn't plan it carefully. So you have to deal with an ugly fraction. Yeah, never mind. You learn more. Carry on. So now what we have is 3x squared plus 3. Factor out the 3. Let's just replace it with square brackets this time. Complete the square. Hopefully you can do it quickly. This is just x plus ugly 3 over 2 bracket square minus 3 over 2 bracket square. Is it clear so far?
Yeah.
Good. Plus 9. Don't forget, I'll put square brackets this time. Y plus divide by 2. So just times 2 to denominator. 5 over 18. Bracket square plus. Sorry, not plus, minus. 5 over 18 square. Close bracket equal to 1. Clear so far?
Yeah.
Good. Then now you try to bring the 3 in. So 3 over 2 square, let me see what it is. This is 9 over 4, right? Minus 9 over 4. This guy there, 5 square, 25. 18 square, I cannot remember. 18 square, 324. So minus 324. Then you bring the 9 in. Bring the 3 in. So we multiply in and we get 3 times x plus. Okay, I don't want to calculate this. I'll just write down as 3 times 9 over 4 plus 9 times. Wow, this is getting quite ugly. Minus 9 times 25 over 324 equals to 1. So a bunch of numbers, right? Don't care. You have a calculator. So what we're going to do next is we're going to bring it over. So minus, bring over becomes a plus. Minus, bring over becomes a plus. Okay, then let's just type this in a calculator. What do we get? 1 plus 3 times 9 over 4 plus 9 times fraction 25 over 324. You end up with 76 over 9. Okay. Then what do you do next? It's 76 over 9. Oh no, it's no longer 1. What do we do?
Divide by 76 over 9.
Exactly. Sorry for the bad planning. Yeah. Yeah, so it's very ugly. So you have to divide by the 76 over 9. So how do we do that? You just multiply by
9 over 76.
yeah, 9 over 76. Exactly. So let me just calculate it in the calculator. 3 times 9 over 76 just gives me 27 over 76. Is that okay? I'm
Yeah.
skipping up steps. Likewise, the 9 you multiply by 9 over 76. So that's 9 times 9 divide 76. 81 over 76. Clear so far?
Yeah.
Equal to 1. Yeah, okay, can. So what do we do next? Do we have this is what shape again?
Ellipse.
Ellipse. So what are the properties of an ellipse? You need center, you need the x radius, you need the y radius, and that's it. So who's the center?
The negative 3 over 2, negative 5 over 18.
Well done. Then what's the x radius? Is it just 27 over 76?
The 7. The
No.
square
What do you
root.
need to do first? Do it. Do the algebra.
Oh, bring it over to the denominator.
Very good. So does
it's
it stay the same?
76 over 27.
Very good. Must swap around. Okay. Then is that the radius already? 76 over 27?
No, must take square root.
Square root and square. Then after that, the other guy do the same thing. Yes. So just take the square root. So tell me what is the x radius and y radius now?
The square root 76 over 27. Then the y is square root 18 over 5.
Square root 18 over 5? Wrong. Y radius.
Oh, the 76 over 18. 81.
Yes. Don't confuse, please. This one is that information is for the y coordinate of the center, okay? Not the y radius. Okay, so yeah, let me just copy this down. Wow, so ugly. Bad example. 76 over 81. But you get the idea, right?
Yeah.
Got one. Then now you have to draw the graph. So let's see. I see numerator here is the same. Denominator is 27 is smaller. So that means that this fraction is bigger, which means that the radius is bigger. So this x radius is bigger. Did you catch that?
Yeah.
Yeah, so anyways, that means it's a horizontal flat one. Maybe it's easier if I just draw the ellipse first, then draw the axis later. Okay, it's supposed to be symmetrical, sorry. And it shouldn't be so sharp at the corner. It should be a bit more smooth. In fact, it should be the tangent over here must be vertical. Okay, yeah, you get the idea. Then you can label. So this one will be negative square root 76 over 27, positive square root 76 over 27. Then the y will be the y radius positive 76 over 81, negative square root 76 over 81. And then center is 0, 0, right? Yes?
No.
Wrong. What's wrong?
It's
No, man, I thought always 0 center. No.
It's the negative 3 over 2, negative 5 over 18.
Need to use this point. So let's just relabel the center this time. Then after that, I shift my x and y axis because I'm using an iPad. I can do that. On paper and pen, no choice. Redraw the whole thing. So let's calculate. This value, okay, let's approximate what's this value. Square root 76 over 27. Make sure the square root is outside. This is approximately 1.67. So I have yeah, so then this is negative 1.5, right? So negative 1.5 here, positive 1.67 there. Where's my y-axis? In between, right?
Yeah.
So I draw my y-axis in between. Must be careful where you draw your y-axis. Very important. So there is a y-axis there. Then where's my x-axis? Here it's negative 5 over 18. There is a negative 76 over square root. I mean square root 76 over 81. So my x-axis should be above the negative, right? But should it be touching? Should it? Well, I give you a few options. Option 1, pass through the center. Option 2, in between. Option 3, tangent to the ellipse. Option 4, directly above. Which one? Which is my x-axis? How? Which one?
The second one.
Second one. Let's see. How do we verify? Okay, so here it is was it positive 76 over positive value here as a y coordinate. So cannot be my y-axis is positive, right? Or y is equal to 0. So it should be below this maximum point of the ellipse. Then here the center is negative 5 over 18. Also cannot. So my x-axis cannot pass through this one. So option 1 is out. Option 3 is also out. Option 4 is even worse. You can't have a x-axis y equals 0 above a positive value. So this is out. So that means you're left with option 2. Your answer is correct. Well done. Okay. Yeah.
Okay.
Very good. So well, not horizontal. Let me try and make it look nicer. Yeah, roughly there, X, and don't forget the origin over there. And that is how you draw an ellipse. Oh, what did I forget to do? I forgot to label the equation. Let me just copy down the original format because it looks nicer. Okay, equation, done. That's it. Origin, I'll just draw a circle there. Okay.
Okay.
Then if you really want to, you can label the coordinates of those 4 points. All right, Ken, that is ellipse. Let's move on to hyperbola. Hyperbola, let's try an easy example. X squared minus y squared equals to 3. How? First step.
Divide by 3.
Divide by 3. So x squared over 3 minus y squared over 3 equals to 1. So hyperbola has a few key characteristics. Has a center. It has asymptotes. And what else it has? It has the turning points. So we'll try to figure that out later. First priority is center and asymptote. Can you tell me what's the center straight away?
0, 0.
0, 0, because x minus 0 square and y minus 0 square. Then what's the asymptotes? Here's the trick. I'll show you first. The trick here is asymptote is basically saying as x goes towards infinity or x goes towards negative infinity, arrow means go towards, what happens to your y? What does it approach? Of course, it will be infinity and negative infinity, but more importantly, you need to figure out in what trend, where's the asymptote? It approaches infinity in what way? So you need to figure out that function y. Okay, in this case, the trick is if you want to do the mathematics, you're supposed to make y the subject and then you let x tend to infinity. That's very long-winded. The trick here is the diagonal asymptote in hyperbola is to set RHS equal to 0. So what do I mean? So copy the equation, but you replace the 1 with a
0.
Then you solve for y. So what do you get? You end up with y squared over 3 equals to x squared over 3. Times 3, you end up with y squared equal to x squared. How do you solve for y? Take the what? Take the
Square root.
What happens when you take square root? You need to have a
Plus minus.
plus minus square root of x squared. Square root x squared will cancel away each other, become plus minus x. And that's how you get the asymptotes. Is it clear?
Yeah.
So what about the the turning points? Is it, what do you think it is?
Square root.
So turning point is very simple. You just need to set x equals 0, set y equal to 0. Don't need to think so hard. Okay? set x equal to 0, what do you get? You get negative y squared over 3 equal to 1, which means that you'll end up with y squared equals to negative 3. Can you have a solution here?
Cannot.
You have imaginary numbers, so no solution, not applicable. NA. Then, so that means that there is no y-intercept. Okay, makes sense?
Yeah.
How about set y equal to 0? You end up with x squared over 3 minus 0 equal 1. Solve for x squared, you get 3, x equal plus minus 3. Square root. Can?
Can.
Then from there you realize, oh, just negative square root 3 comma 0, positive square root 3 over 0. Okay, can we have a short 10-minute break here?
Can.
You go and draw the graph.
Which graph? This one?
Sketch this graph. Yes, try.
Okay.
By the way, positive coefficient of x squared here means that you have a you will have a x shape. Okay. Sorry, I forgot to mention this. The positive sign here tells you that it must be an x shape. All right. Can let's have a break first. I will come back soon.
Okay.
Mic test. Sorry for the interruption. Can you hear me?
Yeah, can.
Can you see the shared screen?
Yeah, do I send you the graph?
Oh, sure.
Oh, okay. I send you already.
Oh, sorry, I haven't checked. Let me open up my Telegram. Okay, and why? Yep, very good. Yes. Dotted line, please. Dotted line. No, I got negative x and positive x. Label the equation. Well done. Okay, Ken. All right.
Okay.
Good. So yeah, with that example done, let's try something more difficult, which is the one where there's x and y terms. So let me plan carefully. Okay, if I want to complete the square, I need a perfect square. 2 squares 4. Let me think of a good example with perfect squares. 9. What else? 7 square 49. Okay. Let's just make it 1. Okay, now I will swap it around. So now this is plus 9y squared and minus 49x squared. How do we draw this graph? First, you must identify it's a conic section because there's x squared and y squared. Then how do we know whether it's a circle, ellipse, or hyperbola?
It's not the same sign.
Plus and minus, so it's a
The hyperbola.
hyperbola. Okay. Then what once do you make sure the right hand side is a
1.
1? Okay, maybe I just be more dramatic and show you an extra step. Maybe at first, oh, it wasn't a 1. Maybe it was a 2, and then here's a 18, here's a, I don't know, 98. Then you have to divide by 2 to make sure it's a 1 first. Okay, then what do you do next?
Um,
What are the 3 characteristics we need? Center. What else we need?
Turning point.
And the
Asymptote.
asymptote. Okay, very good. So let's try to figure that out. What do we have to do here?
Complete the square.
Complete the square. Right. We want to complete the square. Okay. Wait. In this case, yeah, let me just try to make it more complicated. So that we can demonstrate. Let's say we have a minus, I don't know, minus 2x. So at first it was minus 4x. Here, let's say I have a plus 5x. So that means at first it was a 10x. Okay, you know what? That makes my life quite difficult. I'm just gonna choose nicer coefficients. Give me a second to plan this. Okay, let me see. Something that's divisible by 9. How about 18? Something that's divisible by 49. How about oh my goodness, 80. I'll just keep it to 49. Yeah, this is 94. 98. Sorry. Yeah, okay, can. So we start off with this equation. Then we divide by 2 to get that equation. Because the right hand side is now 1, we can proceed to complete the square. But right, this should be a y. Sorry. But then you realize here, coefficient of the x square, coefficient of the y square. It's not 1. So what do we need to do?
Must factorize.
Factorize. So can we try factorizing the first line?
Negative 49
Bracket.
x squared plus x.
Good. Next one.
9 bracket y squared plus 2y.
Okay, carry on. Negative 49, then this one.
Bracket x plus 1 over 2 square minus 1 over 2 square.
Square. Yes, and close the bracket.
Then plus 9 bracket y plus 2 over 2 bracket square minus 2 over 2 bracket square.
Notice that I purposely open square bracket as well. Because what happens to your 9, you need to multiply into not just the y plus 2 over 2 bracket square, but also the
minus, yeah.
The minus part, yeah. Okay, now we can simplify. Negative 49 goes in, negative 49 goes in, become positive 49 half square. 9 times y plus 2 over 2, that's just 1. Let's simplify straight away to 1. Square minus 1 square, which is 9 times 1 square. Okay, what do you do next? Leave the square alone. Leave the square alone. Then you bring the constants over to the other hand side. So so equals to 1, also copy and paste it down. But this fella here and here bring over. So you're left with a minus 49 bracket half square minus, oh no, this one minus bring over become plus. Sorry, you have to be careful about the sign. Plus 9 times 1 square. Is that okay?
Yeah.
Let me copy it down. Clear? Okay, simplify right hand side for me. Did you get that, please?
Yeah.
Did I do that? I hope okay. Correct. I'll confirm.
Yeah, I type into the calculator.
Okay, so good.
Yeah, it's correct. It's correct. I type already.
Correct. Okay, good. So now, how just now I told you just now I told you if you see positive coefficient for x squared, then it must be a x. Can we apply that here?
Cannot.
You see positive here, negative there. Then straight away is a y shape, is it?
No, because the
Why?
right hand side is negative.
What do you need to do now?
You must divide by negative 9 over 4.
Can faster. Okay, divide by the negative 9 over 4. So that means over here the negative becomes a positive. Then you end up with 49 over 9 over 4 times x plus half bracket square. Same thing over here. You divide by negative 9 over 4 plus becomes a minus 9 divided by 9 over 4 times y plus 1 bracket square equals to 1. Okay?
Yeah.
Good. So that means that you can simplify now. You end up with x plus half bracket square over all divided by. This one you must be a bit careful. Maybe we just type in the calculator first. What's 49 divided by 9 over 4? I get 196 over 9. Is that okay?
Yeah.
Then I'll write it down at the side. Then when you bring it down to the denominator, this guy, you have to flip it around, right? So it becomes 9 over 196. Yes?
Yeah.
Other guy do the same thing. So 9 divided by 9 over 4, this becomes 9 divided by 9 over 4 is a 4, It's just a 4. So if you bring it down, it becomes 1/4. Is that okay?
Yeah.
Can, Good. So now you just have to square root square. Square root square. Okay?
Yeah.
Can? And what a coincidence, What a coincidence, Square root 9 over 196 can give you an exact value. It is just 3 over 14. Okay, so let's just clean it up, make it look nice. So we are less confused. So this guy, instead of square root 9 over 196, we can write it as 3 over 14. Likewise, for the 1 over 4, you can rewrite as half. Okay?
Okay.
Good. So now tell me who's the center, who's the asymptote, who's the turning point.
The center is negative half, negative 1.
Okay, Ken?
The asymptote is
what do you need to do? Trick.
Equate the x equals to 0.
Oh. That's the turning point. No, I'm asking for asymptote.
Oh.
Remember this trick. Replace the right-hand side here with a 0. Then from there, you solve for?
So for the y.
Solve for y, because the asymptote is always diagonal line one. Like diagonal line like this. Okay, so it's just a straight line, y equal mx plus c. So make y the subject. So yeah, so and let me just find the asymptote first. Asymptote. In this case, you just need to set the RHS equal to 0. So end up with this guy equals to 0. You can make y the subject. So bring this over, you end up with plus on the right hand side. Can? And then just erase the 0 plus. Then from there, you want to make y plus 1 square the subject. So you can just multiply by half square. Okay, then you end up with y plus 1 bracket square. What do you do next? This guy, number over number. I'll just simplify straight away in my calculator. I'm skipping many steps. You can rewatch the video if you want to know the calculation.
Okay.
0.5 square divided by 3 over 14. 3 over 14 bracket square. You end up with 49 over 9. So let me just erase this part and write down 49 over 9 multiplied by x plus half square. What do you do next when you got a square on the y? Don't expand now. Just take the square root. Very good. So this cancels away. You're left with square root of this guy plus minus. But here, when you take square root of a product, something times something, you can take the square root of each of them. So square root 49 over 9, square root square. This will cancel away with the square. So you're left with just x plus half. This guy's square root, just nice. We can split it out as square root 49 over square root 9, which happens to be 7 over 3. Okay, so we simplify this down to 7 over 3. All right, good. Then we can simplify a bit more. So now y must be equal to -1 plus minus 7 over 3 x plus half. You can do this with pencil and eraser, so you don't need to write down so many things. Right?
Okay.
Just erase and replace. Okay, so simplify. I prefer writing it separately. So split y equals -1 minus 7 over 3 x plus half. Y equals to -1 plus 7 over 3 x plus half. So what you realize is that this one is quite confusing. So I simplify as mx plus c format. Mx plus, okay, this one -1 times, okay, sorry, -1 minus away 7 over 3 times half. Okay, so -1 minus 7 over 3 times half. Type this in a calculator. Let's see what it is. Minus 1 minus 7 over 3 times half. You end up with a -13 over 6. So I'll replace this with -13 over 6. The other guy, I'm not sure. I don't want to guess that it's positive. I'm just going to calculate it. -1 plus 7 over 3 times half. Then I type in the calculator. Change the minus to a plus. Oh, you realize this is positive 1 over 6. Gone. Plus 1 over 6. Can?
Okay.
Asymptote done? Okay, good. So let's just summarize that over there. Write down the two asymptotes. And then you still need a turning point. I need more space. Wait a minute. Okay. What else about the turning point? Set.
Oh, the x and y equals to 0.
Actually, one of them you don't need to set it equal to 0. Actually, do you? Oh, wait, sorry. No, this one center not 0 already. Yeah, so just set x equal to 0, set y equal to 0. Let's just do that. So if x equal to 0, we end up with half bracket square over 3 over 14 bracket square. Then minus away y plus 1 bracket square over half square. Write it down at the side. Don't write it at the bottom because I'm going to draw the graph at the bottom. Equal to 1. So this guy bring over, you're left with 1 minus. So 1 minus bracket half square over 3 over 14 bracket square. You're left with negative. This one bring over becomes a minus. So this entire thing becomes -40 over 9. I'm just going to replace it with -40 over 9. Okay. Then there's a negative and half square at the bottom. So I can just divide by negative, bring over becomes a divide, bring over becomes a
positive
times, right? So times negative half square. So -40 over 9 times negative half square. Negative times negative gives you positive. So 40 over 9 times half square. You end up with. Sorry, I'm skipping a few steps to save time. Is that okay?
Yeah.
Let me know if you're confused. So end up with y plus 1 bracket square equals to 10 over 9. gonna erase the previous working. Gone. You're left with this guy. You can watch the recording later. This guy got squares, take the square root. So you're left with y plus 1 equals to plus minus square root 10 over 9, which means that you're left with y equals to negative 1 plus minus square root 10 over 9. Okay, very good. So that means we have our, what do you call it? Y-intercepts, right?
Yeah.
So what's the coordinates?
The 0, comma, then the -1.
Minus square root, comma, the other one is?
0, -1 plus square
Very
root
good.
10 over 9.
Yeah, that's a plus, plus square root 10 over 9. Hopefully my handwriting is clear enough.
Yeah, can see.
Okay, okay, never mind. I'll just, I hope you can see the comma, it's not a decimal.
Can see.
Okay, good. That is for setting x equal to 0. But now we also need to set y equal to 0, right? So let's just bring it to the side here. When you set y equals to 0, what happens? You're left with this guy equal to 0. 0 plus 1 bracket square over half square. Let's just simplify that first. Okay, actually don't need to simplify. I'll just minus equal to 1. Yeah, actually we should just replace the y with 1. So we end up with a 0 plus 1, which is 1 square over half square. You end up with a 4. I'm typing this on a calculator as I speak. Then minus 4 bring over becomes a plus 4. 1 plus 4 is 5. Divide by 3 over 14 bracket square, bring over. Divide becomes a? Tell me. Times, so that means we times 3 over 14 bracket square. Then how do we continue? Got square here, so what do we do?
Take the square root.
Take the square root, so that means we cancel away this, we get a square root. What's missing? Square root must always have a plus minus. Then from there, you want to make x a subject, what do? Bring the half over. So x plus half becomes x minus half. Okay, minus half, then plus minus the square root of something. So in this case, you can just, okay, unfortunately, there's a 5. So let's just use the decimal approximation now. So negative 1/2 subtract away square root 5 times 3 over 14. Then you must have bracket around the 3 over 14 square. Make sure the square root is over the entire expression. Okay, and you end up with around negative 0.979157, or the other guy, when you change it to a plus, it's a negative 0.0208425. Okay.
Yeah. Okay.
So that's just a y. What do you call it? The x-intercepts, right? So negative 0.979, or negative 0.0208, 0. Okay.
Yeah.
Clear? Good, Can. So now finally we can draw the graph. Okay, so let's see. Where is my okay? I'm just gonna draw the dotted line first. So here's an approximation of the 2 dotted lines. This one is a x shape or y shape. I mean the eventual hyperbola, not the asymptotes. Is it like this, or is it like that?
The first one.
This one is a y. Do you know why it looks like a y? Because you can draw it like this. Some people write their cursive y like this with a tail. It looks like this shape. So it's a, but is this y or is it x?
It's x.
X, because here is positive, okay? Then it's equal to 1. So it should actually be x. So let's just draw the x first. So now we just need to draw the curve first, then we fill in the blanks later. All right, draw the curve first, fill in the blank later. Make sure it's symmetrical. Okay, should be a bit more smooth. Now, let's see. What's the equation of the asymptotes? I mean, yeah, these guys, right? So we just label y equals to Is this correct?
No, it's the opposite.
It's the opposite way, because you want negative gradient and positive gradient. Okay, they both pass through the same fixed point. What point is it? You can simultaneous equation it and you eventually realize it's negative half comma negative 1. Okay.
Oh, okay.
It's the center. Okay, good. So let's see, what's the x and y intercepts? Well, it's a negative. Okay, let's see. Actually, from here, I can approximately guess where is the x-axis and y-axis already, right? Since this is negative half, and this actually goes all the way up. That means that my y-axis must be a bit more to the right. Here, right? But now there's a question. Should it be here, here, or here? Option 1, option 2, option 3. Which one?
What?
Where is your y-axis? Tangent to the curve or intersecting? Which one?
The first one.
The first one. Why? Here, the trick is you must see y-axis versus the graph. If it's over here, is there any intersection with the y-axis?
No.
No, but we managed to find two y-intercepts.
So it's the third one.
Exactly, it's option 3. Okay. See, you don't need a graphing calculator for this. Okay, you don't need. You should be able to tell that is. This is the correct y-axis. Then how about the x-axis? Here's negative. Sorry. Is that right? Did I get it right? Yeah. So here is negative 1, right? So x-axis must be above or below.
Above.
1, 2, 3. Above. So option 1, but there's a few possibilities. Actually, no. There's only one possibility. Sorry. Yeah, there's only one possibility here. X-axis. Okay, then we're done. Okay. That's yeah, that's why you can have two what do you call it? Y-intercepts and two x-intercepts. Just draw a pink color circle like this to identify them. Then you can go and label the points. I'm not gonna do it. You go and figure out which one is which point.
Okay.
4 of them. Okay, then anything else? Something special. There's a turning point here, right? How
Yeah.
how do you identify those points? Use a GC.
GC.
Use a GC. You can draw this graph using the conic sections. I will send you a video on how to do it, but I don't want to go through now. So how do we do
They
it?
will give you the turning point. I thought I cannot trace.
Yeah, so let's try to figure out how do we get the turning points. Hey, let me think a little bit. How did you get the turning points again? Right, it's when the x is not defined. So you set this to less than 0. Less than 0. Let me think a bit. Oh, right. The distance here is it's like a x radius. it can be proven, but I don't think you need to know the proof. Just remember that this is the x radius. So x radius can be obtained from the denominator here. So what's the x radius? It's equals to 3/14. Okay?
Oh.
Is it clear? Like from here.
Yeah.
Oh, so this is 3/14. Then from there, you can determine what is the coordinates of these points. It is along the same horizontal line as that passes through -half, -1. Sorry, maybe the -1 not clear. So that means that this is actually just 3/14 distance to the left and to the right of -half. So this point here must be -half minus 3/14, comma -1, and the other point must be -half plus 3/14 minus 1. Exactly. Then you can imagine it will be the same for the y. It will be the exact same. But instead of x radius, it will be y radius. So let's just do another quick example, okay? For the case where it's a y shape. Okay?
Yeah.
Okay, let me just complete the diagram and label the equation first. So yeah, let's just paste it over here. Okay, good. Then now let's try last example for conic sections where there is just a y shape. I'll just put y squared minus x squared equals to, I don't know, 3 or maybe 4. In this case, first step, you must divide by the 4. So you get a 1. Here, lucky for us, we don't need to complete the square anymore because there is no y term or x term. Then you can rewrite this as y squared over 2 square, x squared over 2 square equals to 1. Then in that case, straight away, because there's a plus y square, you can tell that it must be a y shape. Okay, how about the center? How about the asymptotes? How about the, what's the last one?
The turning points.
Turning point. Okay. What is it?
The center is 0, 0.
Asymptote?
And the asymptote must equate the right hand side to 0.
To end up with? Y squared over 2 square equals to positive x squared over 2 square. 2 square cancel away, y squared equal to x squared. Y equals to?
X.
Plus minus, don't forget. Very important, plus minus, because you have two asymptotes. Always two asymptotes. Then turning point?
Must like equate x equals to 0 and y equals to 0.
Yeah. Oh, sorry, did I say turning point? That's not correct. No wonder I got a bit confused. No, this is not turning point. Sorry, this should be intercepts. Intersection with the xy axis. Can you help me to change that? It's not turning point, it's intercept. Right, that makes more sense. Turning point is the place where it turns, which is this point here. Those are the turning points. Sorry.
Oh.
Okay.
Okay, can.
Okay, so here it's not turning point, it's intercept. Intercept with the xy axis. Then you set x equal to 0, set y equal to 0. Now, when you set x equal to 0, what do you get? This becomes a 0. So y squared over 2 squared equal to 1. Right? Y squared over 2 squared equal to 1. Bring the 2 squared over, y squared equal to 2 squared, which is 4. So y equals to plus minus square root of 2 squared, which is plus minus 2. Can?
Can.
So that means that your your intercept when x equal to 0 is 0, -2, 0, +2. Y-intercepts. Now we set y equal to 0. We end up with 0 equals to -x squared over 2 squared. 0 minus x squared over 2 squared equals to 1. Sorry. Then bring it over, you get x squared equal to -2 squared. -4. Can we solve for x? Take the square root of -4. That will give you complex numbers. Do we want that? Mic test.
Yeah.
Sorry, I couldn't hear your reply. Do we want to take the square root of a negative number?
Oh, cannot.
No, because that will give you complex numbers. So no, you can take the square root, but it will involve complex numbers, which is not relevant in this topic. Complex numbers is self-contained. You will not overlap with the graphing techniques. Okay, can, good. So now how do you continue? That means there's no y-intercept. Then we can just draw the graph already. Dotted line. Please be a bit more generous and give a bit more dotted line.
Okay.
And make it symmetrical, X shape. Then what's the point of intersection here? The coordinates. It's the center, which is 0, 0. Okay. Then that means we can draw our x and y axis already. Okay.
Yeah.
Then, sorry?
Oh, sorry. You cannot hear me.
Oh, what do you say?
Oh, no, I just say yeah, correct.
Oh, okay. Yes, good. Then carry on. So now we need to label draw the curve. So should it be a X shape or Y shape?
It's a Y shape.
Positive here, and it's a 1, so therefore it's a Y shape. So let me just make this go here instead, so I can draw my curve. So we must approach near the asymptote and then go away. Same thing at the bottom. Now, what's the turning point? Here and there. You need to remember that this distance here and there, sorry, they should be the same distance. Okay, let me try and make it look nicer.
So it's square root 2.
Yes, correct. In this case,
square root 2.
no, wrong. No. We already have a 2 square. It's whatever is inside the bracket here with a square. Outside the square.
So
I mean, inside the square. So it's just 2. Yes, this is the y radius this time. You focus on the y over here. Okay. So what's the coordinates of this 2 turning points?
0, 2 and 0, -2.
Very good. That's when it's center at y equal to 0. If its center is, let's say this is 5, then this will be 5 plus 2, 5 minus 2. Is it clear?
Yeah.
Okay, very good. So that is the equation. Let me copy down the equation to complete the diagram, and then we are done. Oh, no, we're not done. Need to label all of the, what do you call it, asymptotes. Y equals to x, y equals -x. Also, coincidentally, the turning point happens to also be the same as the intercept. It's a pure coincidence.
Okay.
Right? Typically, you will have something like this. Intercept 4 of them. Sometimes if it doesn't intersect because of how the graph looks, there may not be all 4 points. Then you also have the turning points. You have to work it out separately. Okay, these turning points. Okay? Can? Okay, good. So finally, we can go to your homework question. Let's see what you did. Yeah, okay. Actually, I don't think I need to go through, right? This one.
Yeah, it's okay already.
Okay, I'll just multiply the x in and you complete the square. Likewise over here, this one is fine. Just label your equation, part B, 2B, 2C. Same thing. Can you tell me what shape it should be straight away? Plus, different coefficient.
It's ellipse.
Ellipse. Then what do you need to do? Can you just write down as 25 over 169?
Cannot, must bring it to the denominator.
Bring down, which is 169 over 25. Then don't forget, you must square root, then square. So the radius is all wrong. Should be 169 over 25 or 16 over 144. Okay, so we can redraw this. I already wrote it for you. Okay, 2D. Let's see. Here your asymptote is wrong. I cannot have x and x, right? What's the procedure again? Pretend the right hand side is a 0. So you try to solve for y. Okay. Is it clearer now? Don't need to go through, right?
Don't need.
Don't need, Yeah, so this is wrong. 3D, 2D, sorry. go and redraw. Also, yeah, okay, that's it. Nothing else to comment on. 2e, here, when you have y square equals something, you take the square root, you end up with plus minus, that's correct. Square root, is it an ellipse? No, it's not an ellipse. What shape is it? Curve like this, okay?
Yeah.
But is it passing through the origin?
No.
No. What you need to understand is it's a translation, you see. This is, let's just focus on the positive 12 minus 6x. How do you start with how do you transform it, graphical transformation into this square root 12 minus 6x? You can start with square root x. Then you change it to negative x, square root negative x. Then you transform into y equals square root negative 6x. Then you transform into y equals to 12 minus 6x. Okay. Yeah. Right. So how do you draw this graph? Actually, you can just use a GC, right?
Yeah.
Let's see. But if you do it manually, square root x looks like this. Sorry, positive square root x looks like this. Then if you become negative, you just have to reflect about the which axis?
The y-axis.
Y-axis, yes. Must remember this, times negative 1. Then when you become 6, it just becomes steeper. There's no change to the diagram. It just becomes steeper, so not much difference. Then now when you have a 12 there, what happens?
Do
you translate 12 units?
No.
In this case, let me just show you the decimal screen. Hold on a second. Share screen to decimals. Can you see the shared screen?
Okay.
Okay, let me show you. This is square root of negative 6x. It looks like this. Okay. Previously, it was y equals square root of 6x. Right? Okay, no, sorry. It was just x. Then it became y equals square root of negative x. Can you see? First one is square root x, then it became negative square root x. Then after that, it becomes negative 6 square root x. I mean square root of negative 6x, sorry. Then now you finally translate it into y equals to square root of 12 minus 6x. Do you see what happened? You go from 0, 0 to 2, 0. How come the translation is 2 units? It's not 12 units. You can think of it like this. Okay, then 12 minus 6x, you can factor out what do you call it? Negative 6. Does it make sense? No? What happens if you factor out negative 6? You end up with negative 6 bracket x minus 2, right?
Yeah.
X minus 2. So it just becomes a translation of plus 2. I mean, translation of 2 units to the right. Maybe I do it in the iPad. Wait a minute. Then it will become more obvious. Maybe the negative should be done as a last step. Okay, so what I mean is over here, 12 minus 6x. So this guy go to this guy. What's happening is you can rewrite this as square root of negative 6x, but the x replaced with, what's that fellow? X plus 2. Can you see what just happened? The x substitute with x plus 2. And these two are equivalent, right?
Yeah.
Correct or not? 12 minus 6x is the same as negative 6 bracket x plus 2. So what we are doing here is this what we are doing here is this guy is like f of x. Then this guy is like f of x plus 2. Can you see that? So when you have +2, what happens? It's a translation by 2 units to the up, down, left, right. Which one? Forget already. Yeah. +2, transform. You graphical transformation. Move the graph up, down, left, or right.
Right.
Wrong. Here, when you see plus, you might intuitively think it's right. Okay, remember that's your answer, but it is wrong. Instead, it should be to the left.
Oh.
Okay.
Okay.
I think I sent you a video on graphical transformations, a playlist, right? The guy in the video, he explained it very well. He just plot a bunch of points for example of a graph. Whenever you have a +2, basically the x gets to be lazier. That's how I think about it. X is like a worker in a factory. When you have a booster +2, the x will become lazier. So he'll put in less effort. Put in less effort means the x becomes smaller. So that's why the graph will travel 2 units to the left.
Oh, okay.
Okay, that's how I intuitively think of it. If it's a plus, reverse psychology. X become minus, negative, move left. +2, then move left. -2, then move right. Okay, plus is move left, minus move right. Okay? So at the end of the day, the graph is just, let me just draw the final graph. Y-axis here, x-axis there, but move left. So like this. Then you end up with -2, 0. Is that okay?
Yeah, can.
That's for positive square root 12 minus 6x, but you have plus minus. Very good. So that means your actual graph should be up and down. Pass through -2, 0. Sorry, my curve not smooth. Let me try and make it symmetrical. Okay, something like this. Can?
Can.
So it does not pass the vertical line test because it is not a function. It is not a function. It is just a graph, a relation. Okay?
Yeah.
Can moving on. 3a is fine, but exact value is preferred. Here, this -2/3. Recurring decimals. You can go figure out 3a. Next, 3b. Here. Your broken line can be more obvious, but the graph is fine. You label the asymptote, very good. No x label the intercept as well, very good. Label the equation, very good. Perfect. Next, 3c. 3c is this guy, right? So this is fine, the equation, but then your graph not correct. Because the asymptote here, you see, it's actually this guy here. The quotient, 3x plus 14. Okay, 3x plus 14. Tell me what's wrong with your graph. 3x plus 14, y-intercept is plus 14, right? How come your graph, your diagonal pass through origin? Cannot be, right? Correct or not? Your x-axis and y-axis in the wrong place.
Yeah, cannot.
And also, I checked with the GC already. You can find the turning points. It's not correctly. You label wrongly. I think so. You label wrongly. Go and check with your GC. This graph has to be redrawn. Do you want me to go through with you how to draw rational functions? Like do long division to get this?
Sure, but it's not correct, man. You mean my long division is not correct?
No, your long division is correct, but your graph sketching is wrong. Your turning points are labeled wrongly. I'm not sure why. I don't know. I'm not sure. Yeah, I'm not sure why actually.
I use the GC and find the turning
points.
So I'm not sure it's correct.
Hold on. Let me plot it again. -9. How did you get that? Let me see. How did you even get that value? Oh, the turning point, if I am not mistaken, this is question 3C, right?
Yeah.
It's at -0.472, -0.8333, and 8.47, 52.8. Okay, it's around 50 plus. Yours 91. Something is off. Something is wrong.
Oh.
Okay, let me just change the scale so that it looks nice. Okay, let me just change the screen to my camera. Hopefully it can be seen. This is the graph. Huh? Okay, let's find our turning point. What do? You press second, press calculate, scroll down to find maximum or minimum. Let's say maximum. So we'll go for the left one. So left boundary, move past roughly the maximum point and then it goes down. So select, then you press enter a few times. You see? Negative 0.47 and negative 0.83. Totally off from your answer. I don't know how you got your answer.
Oh.
Okay.
Okay.
Yeah, I'm not sure how you got your answer, but your long division is done correctly. So I think you just type in wrongly. Do you like forget to put a 60, miss a 0 or something? I have no idea. Also not correct. Yeah, I don't know how you made that mistake. Just go and type in carefully into the GC, okay? Can you know how to find maximum minimum point, right? Yes, no, yes, no.
Yeah.
Yes, just second calculate. Okay, second calculate the trace button. Okay, so yeah, just go and check the solution. This is wrong. Let me just demonstrate. Okay, wait. I finish marking first before I demonstrate. 3D, this one is totally wrong, huh? Just use the graph. How come you only got one diagonal line? Impossible. The graph, if you zoom out far enough, it actually looks like y equals to x as an asymptote, and then it will have a graph that looks like this and a graph that looks like that. Okay. Oh, sorry. No. It has to be approaching the asymptote. So where are the asymptotes? X equal to 0 as well as y equals to x. Let me box up the asymptotes. Then label the equation. Do you know why? Because rationale function, right? This is the quotient. This is the remainder. That is the divisor. Right? So you must recognize straight away. So this guy is your asymptote. Oblique asymptote. Then when you have a denominator x, you just have to equate it to 0, solve for x. Oh, here is already solved. X equal to 0. That's how you get vertical asymptote. Right? Then the remainder here, just park it there. Once you got the asymptotes, you can just draw the sketch already. But whenever you have like two possibilities like this, right? It's either curve like that or curve like that. You have to determine which is which. Okay? So yeah. Let me just yeah, so now let me just try and go through some questions. Should I go through examples? Okay, yes, I should.
Okay.
And this, oh no, this is gonna take a while. What time is it? 10:40. Okay, I need to leave by 1. Yeah, I have to leave by 1. Let's go. So let's go through this. So let's start with one example. Y equals to, this is rationale functions. How to sketch rationale functions. Rationale functions means you got fx over gx. Let's just go through a few things first. Degree means what? Degree definition means the highest power. Okay, so for example, x cubed plus x power 2 plus x plus 1. What's the degree of this expression? What's the degree? Highest power.
The cube.
3. Degree is just a number. 3. Okay, so when we say what do you call it? Proper fraction, what do we mean?
The numerator, the highest power is lower than the denominator's highest power.
Can it be equal?
Cannot.
So degree of fx must be strictly less than degree of g of x. Okay. Highest power of the numerator must be strictly smaller than degree of denominator. If it's exactly equal, you have to do long division. If it's bigger or equal, you just have to do long division. Okay, so yeah, let's try this. Y equal to 3x over x plus 4x minus 2. Straight away, you should realize something. Oh, degree here is, highest power is 1. Correct or not? Power 1. Here, degree is x times x gives you
X square
square, so degree is 2. Is it proper or improper?
is proper.
Proper. Do you need to do long division?
Don't.
No long division needed. So then you carry on. How to draw the graph? So over here, what you should realize is that x, what do you call it? There is no plus something, right? The quotient. So that means that it's actually plus 0. Plus 0. So that means that you actually have an asymptote, which is y equals to 0. Clear? So we can draw a sketch already. Let's just draw the y-axis and x-axis. You straight away have y equal to 0. Sorry, x. Is it y equal to 0, x equal to 0? It's y equal to 0, sorry. Y equal to 0 as an asymptote. Okay, so then let's think about it. Where's my vertical asymptotes or oblique asymptotes? Actually, this guy here is your oblique / horizontal asymptote already. Okay, remember it's always of this format. Y equals to the quotient of x plus the remainder of x divided by the divisor of x. Okay. And then the dividend. Okay, fx divided by the divisor of x will give you quotient of x. Then you do the work. Eventually, you'll get a remainder of x. Oh.
Yeah.
Okay. Yeah. So anyways, that's a general formula. Huh? You do actual examples will make more sense. If you see this fx, dx, rx, qx very confusing. Must do actual example. But here is already done for you. So you just need to recognize the pattern. How do you identify the asymptotes? The trick is you must identify the plus qx here as well as the dx there. You must set this guy equals to 0 and you must set y equals to qx. Those will be your two asymptotes. And solve for x. I mean, these two will be your asymptotes. So over here, there's an x plus 4x minus 2, so you should set it equal to 0, right? Just nice, very nice. I factorized for you already. So straight away, you can get two solutions, -4, +2. So where are my asymptotes? X equals to -4, x equals to +2. Then how to draw the graph? This one, actually, you can just, now I'm doing it manually because sometimes the question will change this into x plus a, x minus b, then you must do it manually. Oh, of course, you can use a GC, obviously, but I'll show you the manual way so you can deal with the general case in the future. All right, Can? Yeah, so how to draw the graph? So that's when I will plot a few points. When it's like -10, okay, for example, I'll just type in the GC or type in a scientific calculator. You should realize that you get like -30 over -10 plus 4 is like -6. -10 minus 2 is -12. Negative times negative gives you positive. On top is negative. So overall is a negative. So that means you'll be below the curve. I mean below the x-axis. The curve will be below the x-axis. Is that clear?
Yeah.
-10 comma negative. So that means that your curve must look something like this. Because you must pass and when x is -10, it must pass through a point which is below the x-axis. And there are two asymptotes here and there. So the only way is for the curve to go towards the asymptote like that. It cannot be this curve anymore. Now for the next one, there's a few possibilities. It's either curving like this, tending towards the asymptote like that, or curving like this, tending towards the asymptote, or it could be curving like this, or turning like a tangent graph, or maybe a reciprocal, maybe a negative tangent graph, tangent negative x, or it could be curving like this, which is directly the tangent. So a few possibilities. How do you determine which is which? You just have to plot a point. Let's say at x, the x-intercepts. So when set y equal to 0, what do you get? This guy will be equal to 0, right? Clear so far?
Yeah.
You don't have to label this point. Maybe I will just write down in red color those that are not relevant. Red color means you don't need to draw. Black color you must draw. Equal to 0, then therefore 3x equal to 0. Denominator times 0 is 0. So solving for x, you get x equal to 0. That means that this graph must pass through 0, 0. This point here. Is it okay? Okay. And now we have to check. Would it go up, down? Up, up? I mean, positive, 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 negative, negative, positive, or negative, negative. You just have to plot a few points. Let's say we pick a point that's x value that's in between -4 and 0. Pick an x value in between -4 and 0. So let's say, what number would you like? Pick a number in between -4 and 0, please.
-2.
-2, okay, sure. Then you check sub into the function. So you get 3 times -2, y equals -2 plus 4 first. -2 minus 2. This will give me a what number?
It's a fraction.
Positive or negative?
Is positive.
Okay, positive. That's the main point. So that means that when x is -2 here, it will pass through a positive point. So somewhere here. Okay, then how about when it's let's pick a number that's more than 0 but less than 2. So how about x equal to 1? So y equals to 3 times 1, 1 plus 4, 1 minus 2. Plus or minus?
Minus.
Minus. Okay, very good. So that means it will pass through a point over here. So how does the graph look? Can it be like this? No way. You need to pass through here, here, and here. How about like this? Approaching the asymptote. Cannot. You're missing that point. How about like this? Can it be?
Cannot.
Cannot. So there's only one option left, right?
Yeah.
You can just erase those points and then just draw a nice smooth curve like this. Okay? Understand now how to draw manually?
Yeah.
So later when it changes to x plus a, x minus b, you also know how to draw, right? You just have to test the point. X equal to x equal to something, x equal to something. Okay? How about the last part? You have two ways, because there's an asymptote here, you need to approach. It's either curving this way or curving this way. How? So you need to check what happens when x goes towards positive infinity. What happens to this fraction? Does it become more and more positive or more and more negative? I pretend x is like 100. When x is 10, x is 1, x is 10, x is 100, x is 1000. What happens to the y value? Does it get bigger and bigger or smaller and smaller? Let's type in a calculator.
Oh. It becomes smaller.
Smaller. Very good. Yes, because there's an x square over here. The reason why it gets smaller is because essentially it's just 3x over x square plus something, right? So what happens when there's a square here? The x square will grow bigger than the x, right? So denominator will go to infinity, infinity. This one will become just infinity. So who is bigger? Denominator is bigger, which means that the fraction will get smaller. So you'll go towards. So the y will grow towards 0. Correct or not? positive 0 lah, huh? Because x is positive here, x is positive here as you let x go towards positive infinity, which means that you'll get positive divided by positive, which is positive. But you realize that the pattern is the denominator grows so big, infinity square versus 3 times infinity. The square makes it grow so much faster that it will go towards 0. So that means there's only one possibility now. Sorry. I realized I made a mistake just now. I say is this curve or this curve is wrong, because there's actually a y equal to 0 asymptote, right?
Yeah.
So it's either this curve or that curve. How do we test which is which? Sub in x equals to a value which is bigger than 2. Correct. If it passes through this point, it will curve like that. If it passes through that point, curve like that. There's only one choice. You just have to sub in. So maybe sub x equal to, can you pick a value of x that's bigger than 2? Let's say 1 million, 1,000. Then I don't need to care. Y equals to 3,000 over 1,000 plus 4, 1,004 times 1,000 minus 2. So, well, minus 2 is really insignificant. It's just still positive, right? We end up with positive, positive, positive. So overall, it's a plus or minus. Hello? Positive, right? Don't need to even care about the value. Don't care lah, whatever. It's just a positive number. So that means it must be above the x-axis, somewhere here, right? Then there's only one possibility for the curve now. Can it be this guy? Like this? Can it pass through this point?
No.
No, right? Because it will be positive, some positive 0.000 something. So that means that we'll just have to have this as our only possible curve. And that's how we sketch the curve. Don't forget to label. No space or I don't label. Is that okay? Clear? Yes, no, yes, no. Confused. Which part?
Yes.
Yes, huh? Okay. So that's a procedure. Just check the proper, improper first. Improper, long division, proper, then carry on. Figure out the asymptotes. Draw the asymptotes first. Dotted line. Please be more generous with the dotted line. Be more generous with the dotted line. Label the equation of the asymptotes. Then you draw the curve. How do you check whether it should be above or below? You just need to plot a few points. Plot a few key points. How to determine whether it's above or below the x-axis. Okay, that was in words. Do I need to write it down?
Don't.
You want me to write down? No need, Then I move on to another example.
Okay.
Okay, next example, let's go. Just give lots of examples. I think it's easier to explain that way. Easier to understand. Next example, let's say we have 2x plus 1 over x plus 2. Okay. Now, straight away, you can tell this is proper, improper. Proper, improper.
Is improper.
Improper because degree 1. Okay, I don't bother explaining. So straight away, you do long division. So 2x plus 1 over x plus 2. Now, 2x divided by x, you get 2, right? So I like to keep my constants in the same column. And all my terms that are the same degree, we keep them in the same term. Same power of x, we keep it in the same column. So 2 multiplied to the x plus 2, you get 2x plus 4. Subtract bracket. 2x minus 2x, 0. 1 minus 4, you get negative 3. 3 is times x power 0. 0 is smaller than power 1, so we stop. This is our remainder. Final answer must be 2 plus negative 3 over x plus 2. Clear?
Yeah.
Okay, transfer over. So that means that I have asymptotes. What are my asymptotes? Y equals to
2.
2. Okay, actually straight away just draw the graph. Y equal to 2. So with the power of technology, I can draw dotted lines instantaneously like this. You use a ruler.
Okay.
Let me just change the color to. Wait a minute. Let me just do some settings. Okay, yeah. So y equals to 2. And then what else? What's the other asymptote? What's the other asymptote?
So x equals to negative 2.
Equate the denominator to 0. That's the main idea you should remember. Denominator equal to 0. Then solve for x. There may not just be a single asymptote. Just in this example, there is only one. So x equal -2. So let me just draw it in. X equals to -2. Origin here. Y-axis there, x-axis there. So now we have a few possibilities. In order to approach the asymptotes, right, you can either be for the left half, this guy or this guy. For the right half, that guy or that guy. So how do you think we can determine which is which? For the left half. Sub in x with
0.
left half. I want to determine the left half. Definitely doesn't pass through x equals 0. That's for the right half already. Left half. To the left of the -2. So sub in x with any value that is less than -2, right? Can you try? Give me an example.
-3.
Of course. Okay, -3. Then just type in the calculator. 2 plus -3 over -3 plus 2. You get some number, plus or minus. I don't care about the value.
Plus.
Positive. You sure? Yes, correct. Yes. Okay, then that means it must be positive. What's actually, this guy is positive. So, oh, that's not conclusive. Sorry. Because here it's y equal to 2. If it's positive, it could be positive 2.1 or it could be positive 1.9. Then we don't know which is which. So can you tell me what's the actual value? Positive what?
3.
Oh, it's positive 3, is it?
Yeah.
Let me see. Positive 3, not positive 5.
Oh, I never passed right the 2.
Yeah, just type carefully. So positive 5, right? Okay. So now we know 5 is above 2, so that's why it's above. This guy is out. Wrong. Okay. Then from there we can tell straight away the curve must be like that. For the left half. Okay, you must always look at vertical line and figure out left half, right half. Okay, to pass vertical line test. Right. If it's both curve, does it pass vertical line test?
No.
No, vertical line test only requires a vertical line to cut the graph only one time. Okay, moving on to the next part. You are saying x equal to 0, right? So let's just do that. Straight away, you should be able to tell this is y equals to 2 plus -3 over 0 plus 2, right?
Yeah.
-1.5, that's 0.5, right? Yes, no?
Yeah.
Good. So that means that you have 0.5, 0, 0.5. Here is x equal to 0. Where's 0.5? Above or below 2?
Below.
Below 2, so somewhere here, right? Then we can just draw the curve already. There's only one possibility like this. What else should we find? You should always find the you should label equation. Then you need to find intercepts. You also need to find asymptotes. Okay, these are 3 that's the most important. Yeah, so for a graph. So what else is missing? We got x equal to 0. That means this is your y-intercept. What else is missing? Not y, but rather the
x-intercept.
X-intercept. So sub with what?
Y
equals to 0. Very good. So sub y equal to 0, we get 0 equals to -3. 2 minus 3 over x plus 2. Now, that's not very smart because actually this function is easier to use. We should instead use the original function 2x plus 1 over x plus 2. Why? Because the algebra is easier. Divide by x plus 2, bring over becomes times. So 0 times anything is just 0. We end up with just 2x plus 1. Is that clear?
Yeah.
Good. Then from there, you can solve for x equal to -half. So that means you pass through -half, 0 over here, -half, 0. Okay. Then this guy is 0, +half. And then we are done. Okay, maybe I change the font size a bit. +half. All right, Ken?
Yeah.
Very good. Then don't forget to label. Yeah, okay. Label already. Okay, just beside it. Technically, you should draw it again. 2 plus -3 over x plus 2. You take out the negative also, okay. Never take out also fine. Clear enough. All right, Ken?
Okay.
Good. Now, did I miss anything? No. Next example. Let's try another example. Wow, Go. Must keep giving examples. Rational functions, very important. Next example I want is 3x minus 6 divided by x plus 6. Rational, irrational. Sorry, rational of course. But is it proper, improper?
This one is proper.
Proper. Why? Degree 1 here, degree x times x is 2 here. So what are the asymptotes here?
The x equals to negative 6, x equals to 0.
And one more. Y equals?
Y equals to 0.
0. Yes, there's a plus 0 here, the quotient. Okay. Hidden y equals to 0. How do you tell that y equals to 0 is an asymptote? As x approaches infinity, what happens to this guy? Infinity, then this one infinity square plus 6 times infinity, right? X square plus 6x.
Oh, so it's a lot bigger.
So the denominator is a lot bigger, which means that the denominator will grow faster. It's like if it's like 1 million here, it's only 1,000 there. So the 0 cancels, but then you're left with 1 over 1,000, which is a very, very small number that's very close to 0, almost 0. Okay, so that's why you have y equal to 0. But now we have to figure out how to draw the graph now with the asymptotes. So let's just do a quick one. So over here, you got minus 6 and 0. So that means that maybe I'll move it over. X equals to negative 6 here. X equals to negative 6 here. And x equals to, very messy. X equals to, I want a solid line. X equals to 0. Then now we have to figure out, one more. Y equals to 0. Oh. You don't have to draw the dotted line again because it's intersecting with the x-axis. Just make sure you label. So you can tell the examiner, I know this is the asymptotes. Then after that, you just sub in a few points. So I see to the left of negative 6, so how about x equal to negative 1 million? Negative 1 million. Why do I want that? Because straight away I see 3 times negative 1 million becomes positive times negative gives me negative. Negative minus 6 is y equals to negative. Divide by, if it's negative 1 million, the purpose of choosing such a big number is for you to not key in the calculator and think a little bit. X is negative here. Negative 1 million plus 6 is still negative. Negative times negative gives you?
Positive.
Positive. So you don't even need to know the value. At the end of the day, it's a negative value. If it's negative, it means it's below x-axis, so over here. Then there's only one possibility for the graph, like this. This trick only works when it's a y equals 0 as an asymptote. Okay.
Oh.
Actually, I mean, if it's y equals to positive 2, then it also works out because negative, this is probably a very big negative number. Is it not? Oh, no, sorry. It's very, very close to 0. But it's still negative. So it's still below 2. Yeah, just be strategic. The best solution is just to key in and get the actual value, I guess. Just maybe you put negative 10. I don't know. That also works. But I just know that at the end of the day, we get negative and we know the graph will look like that. Then how about in between? Minus 6 and 0. Just sub in with a value in between, let's say with negative 1. So we end up with y equals to 3 times negative 1 is minus 3, minus 6 is minus 9. Negative 1 means negative here, minus 1 plus 6 is plus 5. So this is positive 9 over 5. Okay, so it's positive. Then there's only one possibility now. I mean, okay, no, not one possibility. It could be here, it could be here, could be here, could be here. So we need to figure out a few more points. Let's say, yeah, no choice. This one I have to plot a few points. Let's say it's very close to negative 6, so negative 5.9, right? Negative 5.9 is here. Then figure out the y value. Can you tell me what is it? Okay, to save some time, I got the value already, 40.169. Okay, so it's above. Then if you plug in another point, let's say is negative 0.1, this will be y equals what? By the way, let me show you a trick. Let me see. Camera. Can I change to camera? Is it showing? Okay,
Yeah.
good. So, okay, the brightness. Let me increase brightness. Now, what I did here is I key in negative 0.1 and I get my answer. Then what I did was I already keyed in this expression. Can you see this expression?
Yeah.
ANS. So when I store in, let's say, negative 0.1, I press equal, I will store this as answer. So what I do next is I go back to this expression, I type in ANS button is over here. Okay, ANS. All right, you just press ANS and then you press equal. The ANS is currently negative 0.1, the most updated answer. You press equal, you get the answer, positive 10.6. Okay, likewise, if you want the ANS to be like just now the negative 5.9, you just key in negative 5.9 equals, and then this will be stored as your ANS already. If you key in ANS, you press equal, I hope it's clear. You'll just get the negative 5.9. Then you can just go back and type in. Here, I'm clever. I never press the on button after I key in. I just press the up. I can check my history. Then I press left. I'll go here. Then I can press equal. Or you just manually type it. You'll just get the answer. This negative positive 40.169. That's how you type it fast. Okay. Yeah, you can use ANS, but you must make sure you know how to use ANS. Your ANS is your direct previous answer. You must check your ANS first before you go and key in if you're not sure. Clear?
Okay.
Okay, anyways, I got the two values already. Yeah, you can go figure out slowly. What is the value? Is 10.67. I don't bother rounding off because I know that it's just a positive value that is more than 9/5. Okay, so somewhere here. Then from there, you can figure out, it must be a happy face. Now, take note that, what's it? I don't need to label those coordinates. I mean, those points. Take note that the turning point is still unknown. How do you find turning point? Is it the middle? Is it -3 here? Definitely not. You need to do differentiation. Differentiate equal to 0, solve for x. I mean, to find turning points. Okay. Last one. Let's try. You got y equal to 0, x equal to 0. So it's either on top or below. Which one? Sub in x with, let's say 1. Bigger than 0. So you end up with something. What is this? 3 times 1 minus 6 over 1 times 1 plus 6, which is 7. You end up with a negative value. So that means it must be negative. Then you can draw the curve straight away. To find the turning point, you have to differentiate. So let me demonstrate dy by dx. Now let's try quotient rule. Okay. Do you recall quotient rule? You did it wrongly just now in one of the questions. How to use quotient rule? Can you remember this? Low d high, less high d low. Draw the line and square below. Did you catch that? Less. This is read as less. High d low. High d low. Draw the line and square below. Low square. D means differentiate. Low d high, less high d low. Draw the line and square below. Draw the line and square the low. Square below. Is it clear? Is it clear? Let me demonstrate now. So this one, maybe I expand as x squared plus 6x. I mean the denominator expand as x squared plus 6x. Then we do low d high less high d low. So low is x squared plus 6x. Multiply by d high, so it's a 3. Minus sign low, less than high d low. So high is 3x minus 6. Differentiate the low, so we get 2x plus 6. Draw the line and square below. So x squared plus 6x. Then you square it. Is that okay?
Yeah.
Then for stationary point, here's the standard presentation I have. I differentiate already. Then I write down for stationary point, dy dx equals 0. So you just copy the expression equal to 0, which means numerator equals to 0 because denominator times 0 just equals to 0. If you want to solve this, you can bring the divide by whatever over. So 0 times something gives you 0. That's good. Then we can carry on. Just solve for this equation. So we end up with a quadratic, right? 3x squared plus 18x Then this one, no choice, have to multiply 6x squared. Minus 6 times 2 is minus 12x. Plus 3 times plus 6 is plus 18x. That gives you a positive 6x. Minus 6 times positive 6 get negative 36 equals 0. Distribute, you end up with minus 6x squared minus 6x plus 36 equals 0. Simplify a bit more, minus 3x squared. 18 minus 6 is plus 12x. Then you have plus 36 equal to 0. You can divide by negative 3, so x squared negative 4x divided by negative 3 is negative 12 equals 0. This one can factorize or not? Can, you get x minus 6x plus 2. Right? End up with x equal to 6 or x equal to negative 2. Is that right?
Yeah.
Hopefully. I was doing a bit faster. Yeah. Okay, then that means that your corresponding y coordinate, do you sub back into the dy by dx expression or the original y?
The original.
Original, very good. Only focus on the original. So let me copy down the equation, then we can solve for y. When x equal to 6, we get y equals to, I'll just key in the calculator, 3 times 6 minus 6. Or you can do the trick, press in a 6 first and store as your a and s. Then you just use a calculator to type in. You'll just get 1 divided by 6. Alternatively, this guy will be when x is negative 2, you just type in terms of a and s and you will get 3 over 2. Okay? I show you what I'm typing. So basically, my calculator, I never press on all the way. So I just need to key in, like, for example, x equals to negative 6. So I just key in negative 6, I press equal sign. This will be stored as my a and s. I press up to get my history. I realize I get this guy. And I press the left button. I press equal. Hey, math error. Okay, hold on. What did I do wrongly? Let me see. I wanted, was it negative 6 or positive 6? Oh, it's positive 6, sorry. So I press positive 6 here. I press equal. I go up to get my history here. I press left. I press equal. And then I get 1 over 6. Then you can do something similar for the rest. Okay? Can?
Okay.
Okay, back. So carry on. 1 over 6 and 3 over 2. How come got 2 answers? What does it mean? Does it mean that, what does this mean? It means that maybe I draw my graph wrongly. Is it?
Must reject one of them.
No, it means I draw my graph wrongly, not reject. It means that it's not always that asymptote must start here and end here. You can always have a curve that looks like this. Did you see that? There is another hidden maximum point here, local maximum point. Did you catch that? That's one of the mistakes you made in your solution. Your asymptotes doesn't mean that you always never pass through it. There's an asymptote here, but it passes through it. Asymptotes actually by definition it's not that you never pass through it. It means that when x approaches infinity, the y will approach that asymptote value, in this case, 0. Only when x is nearing infinity. When x is small, in this case, when x is like tiny little numbers, I'm not sure what number it is. You can find it, we can find it later. Your graph can still intersect with the x-axis. Is that clear?
So it still can pass through.
Yes, correct. I didn't know this. Common misconception. Okay, common misconception. Yes, you can still pass through when the value of x is small. Okay, let me just adjust my graph to make it look nicer and more accurate. Why are you? How to make it? Yeah, okay, shouldn't intersect. I cannot intersect. Okay, you see, I made a mistake here. I intersected with the axis. Shift it a bit to the left. Looks better. Okay. So there's like a gap here. There's a gap here. Then you can find out the gap here by treating this by multiplying over and then treating as a quadratic in terms of in terms of x, treat y as a constant, then you use the discriminant b squared minus 4ac. Recall a similar question you did? Yes, b squared minus 4ac? Similar, this is the same idea. Okay, I'm hinting to you. Okay, so basically there's a turning point over there, which is negative. Oh, sorry. Oh, sorry, wrong direction. Yeah, my mistake. Okay, by the way, can you help me to type this inside the graph now? Y equal 3x minus 6 over x times x plus 6. Type in the GC. Make sure your scale is big enough. I mean, yeah. Yeah, so it should be a bit nearing to the x-axis like this. Don't draw in a single stroke. Do not like sketch. Okay, don't sketch your curve like this. Okay, don't do that. You are not an artist. This is our math class. You have to draw it in a single line. If it's wrong, you erase and redraw. Go up a bit and then you curve down like that. Okay. Do you get that graph? Hopefully.
Yeah, have. But then
don't have the turning point. Have or don't have? I hope it has. Supposed to have lah. Let me see if I did it wrong.
Must zoom in and see. It's very small.
Yeah. Unless I got it wrong. That could also be a possibility. Let me see. Hold on a second. Maybe I should just use decimals so it's faster. 3x minus 6 over x times x plus 6. Right. Did I calculate wrongly? I might have calculated wrongly. Supposed to have a turning point at x equal to 6, 1 over 6 and negative 2, 3 over 2. Oh, right. Sorry. I was right the first time, the graph. Can I just redraw this? This is correct. This is the correct graph.
Oh.
Yeah. You can go and find out. This one is 6, there was a 6, 1 over 6. The other guy is negative 2, 3 over 2. Yeah, I was right the first time. Yeah. Okay. Clear, there is a turning point here. Actually, I realized that this is 2, 0. You can also figure that out by substituting y equal to 0. Okay. This one can sub y equal to 0. Of course, all this can be done using a GC, but I'm just doing it manually to show you that you can do it without a GC. Also, this graph is very good example because it tells you that many different things. Common mistake here and here often left out. Okay, you assume that it's actually this curve when it's wrong. Clear?
Yeah.
2 main points. First one is there's a hidden turning point. You need to zoom in to the correct scale to see it. Second point is here there's a x-intercept, which is the same as the x-axis happens to also be the asymptote, which means that for small values of x, it is possible for the graph to intersect with the asymptote. A lot of students will think, oh, asymptote then cannot pass through, but that is not true. Okay.
Okay.
Yeah. So let me think. What was that function I wanted to give you? Okay, no. Let's go on to the next example. Okay, go. This is turning points. Okay, next example. Let's go. What was the next example I prepared? X squared plus x minus 1 over x minus 1. Okay, now this one, the proper, improper, straight away you can tell x squared over x, so must be improper. So straight away do long division, yeah?
Yeah.
Divide, you get x times x, get x squared. Distribute, you get x squared minus x. Subtract away, you get 0. X minus x becomes x plus x, which is 2x. Bring down the minus 1. Now, can we continue? Yes, because degree 1. Still can. 2x divided by x, you get plus 2. Multiply, you get 2x minus 2. Subtract, bracket. You end up with 0. Minus minus 2 is plus 2, so we get a positive 1. Then you stop. So answer must be quotient plus remainder positive 1, don't need the plus, divide by the divisor x minus 1. What are my asymptotes?
The x equals to 1.
Okay.
Y equals to x plus 2.
Okay, I show you the extremely messy way, but still acceptable one. X equal to 1 as well as x plus 2. So where's x plus 2? Y-intercept plus 2, right? Positive gradient, right? So it must be like this. There's only one possibility. It must be above the x. So let me just shrink my diagram down a bit. Then after that, okay, I try not to use the iPad functions, and I show you I can draw this freehand and it still looks okay. Then I can have x plus 2, y equal x plus 2. Now there's a few possibilities. It's either curving this way and this way, or it's curving this way and this way. How do you check which is which? Use minus 1 as a reference point. Sub in a point less than -1, more than +1. More than +1, sorry. Less than +1 or more than +1. Okay, so let's try x equal to 0 because it's easy. Then I can get y equals to 0 minus 1 over 0 minus 1, which is +1. So it must pass through 0, +1. Here it's a x plus 2, right? So +1, is it above or below?
Is below.
Below, so we cut through a point over here. Then we know straight away, it must have a curve that looks something like the following. Okay, but there's a problem. There's a turning point, right? That's the only way to have reached the asymptotes. Where's your turning point? It could also be, I don't know, maybe my graph wasn't clear enough. Then maybe the turning point was to the left of the +2. Or it could be exactly at the 2 itself. Okay, that's very messy. Did you catch that?
No.
Okay, wait. I redraw. So what I mean is, this is one possibility, but you could also have the turning point to look something like, make another duplicate first. You could also have the turning point to be slightly towards the left side of that intersection with the y-axis. The turning point could be there at the top, right? Can you see or not?
Yeah.
So it's to the left, or it could be slightly towards the right. So I mean something like this guy here, or it could be exactly at the point itself, the turning point. Correct? These are the three possibilities. Turning point is to the right, on the point itself, or towards the left. Okay?
Yeah.
I'll just keep this here at a corner as a reference. So we don't know. Then that means that we have to, I think the best way is to just use a GC now. Of course, you know the procedure, right? Differentiate, equate, 0, solve.
Yeah.
Yeah, so actually we can, let's just do it manually. So in this case, which one do you think is easier to differentiate? The left one or the right one?
The right one.
The right one, of course. So dy by dx, straight away we use the right one. Differentiate x plus 2, you get 1 plus 0. Plus this one is a quotient. You differentiate, what do you get? You end up with a -1 over x minus 1 square. Did you catch that?
Yeah.
Then chain rule, differentiate the x minus 1, so you get a +1 times +1 minus 0, which is just times 1. Okay, and then we are done. Now, what do you do to solve for x? Solve for the stationary points?
Equate to 0.
Equate it to 0. So for SP, you set the dy by dx equal to 0. That means that this entire expression equals to 0. Solve for x. So -1 over x minus 1 bracket square equals to -1. Flip it upside down, you end up with n times -1. Okay, maybe I times -1 first, then I flip it upside down. So x minus 1 bracket square over 1 equals to 1 over 1 is still 1. Solve for x, you end up with, x minus 1 first, then you end up with plus minus square root 1, which is plus minus 1. Bring the 1 over, you end up with 1 plus minus 1, which is x equals to 1 minus 1, or x equals to 1 plus 1, which is 0 or 2. Okay.
Yeah.
So conclusion is, what if you sub in x equal to 0 back into original function, you end up with 2. That's 1 point. Or 2 comma sub into the y and you end up with, let me see. When x equals, okay, I'll copy down the expression first. When x equals to 2, I end up with 2 squared, which is 4, plus 2 minus 1 over 2 minus 1. This gives me 5. Okay, so 0, comma 2 is a turning point. 2, comma 5 is another turning point. Is that okay?
Yeah.
0, comma 2, 2, comma 5. 0, comma 2, 2, comma 5. So where's your turning point when it's 0, comma 2? It's over here, right? So which option is it? Option 1, 2, or 3?
The second one. The third one.
The third one, the third one. Okay. Second one is when the turning point is slightly to the left of the y-intercept. For option 1 is slightly to the right. Option 3 is exactly at the 0, comma 2. So really, you must check the graph GC to be careful to plot the graph correctly. So it has to be that turning point. It's not always the case that it passes through the turning point is the y-intercept. You must really go through this procedure. Differentiate equals 0, solve for x. Okay. Then of course we also found out that there's a turning point at what point? 2, comma 5, right? So it also means that 2, comma 5 must be on the graph. When x equals to 2, what is y equals to x plus 2? It's just 2 plus 2, which is 4, right? So it passes through 2, comma 4. But our graph actually passes through 2, comma 5. So it's slightly above at the turning point there. So that means that maybe if I just shift my turning point a bit to the left side, the graph should look something like this. Correct?
Yeah.
Cannot be below, right? Because it's 2, comma 5.
Yeah.
Okay, that's how you draw the graph. Easy? Good. Can?
Okay.
Okay, I forgot to label the equation. Okay, I mean it's above. Maybe I'll just copy and paste it over here. Okay, then we are done. And label the turning points. This one 0, comma 2. Oh, I forgot another thing. The x-intercepts. Just set y equals to 0, then solve for x. So in that case, you end up with x squared plus x minus 1 equal to 0, solve for x. Can I leave that to you to do on your own? Can? Okay, good. That's the equation. Moving on, next example. Another one. Let me see first. Hold on a second. Is this useful? Should I go through this? Let me think a bit. Yeah, okay, yes. Just all the different permutations of a graph. Just go through everything. Don't say I never cover. Next example, y equals to x squared minus 18 divided by x plus 3. Okay, so proper, improper?
It's improper.
Because degree 2 over degree 1. So that straight away you need to do what?
The long division.
Long division. Here I have to be a bit tricky. X squared minus 18, I will obviously add in a 0x minus 18. Okay, usually it helps students when you put in a 0x, less confusing. Then you divide by x plus 3. Highest degree divide x squared divided by x, you end up with a positive x. Multiply in, you get x times x, which is x squared, x times 3, which is 3x. Minus bracket, subtract away, you get 0. 0 minus 3x is minus 3x. Bring down minus 18. Degree 1, can you continue? Or is this a remainder?
Can continue.
And continue. So negative 3 divided by positive 1, you end up with negative 3. Multiply in the negative 3 into each of them, you get minus 3x minus 9. Minus bracket. Subtract, you get 0. Subtract minus 9, you get plus 9, which is a negative 9. That's your remainder. Answer equals to, tell me.
Negative 9 over x plus 3 plus bracket x minus 3.
Okay, wait, let me, sorry, say again.
Negative 9 over x plus 3 plus bracket x minus 3.
Okay, can. Good. So who is the asymptotes?
The
are the
y
asymptotes?
equals to x minus 3 and x equals to negative 3.
Okay, very good. So let me just plan out inside my head. So it's like here and here. And I need x and y there. So that would probably mean I need more space on the left side. So that means I should start my x and y axis nearer to the top right corner. X axis here, y axis here, x minus 3. Oh, wait. Probably a bit more up. Here, x minus 3, where do I draw my graph? I give you 3 options. 1, 2, 3. Which one? Pass through origin, above or below?
Below.
Below, very good. Option 3, Can? Okay, good. So yeah, let's just plot that point there. This is negative 3, y equal x minus 3. But something wrong? What's wrong? Asymptote. Can you put solid line?
Cannot, must put the
Cannot, must be
dotted
dotted
line.
line. So let's try that instead. Okay, technology, I can draw dotted line. Okay, now this guy, you got negative 3x equals, right? Vertical or horizontal? Up, down, or left, right?
Is vertical.
Vertical, okay. So yeah, so like that. Okay, good. Wow, no space. Let me just move it a bit more to the right. So I have more space. Maybe, you know what? Let's just move the y-axis because I have technology. I can do this. Yeah, okay. Then I will have more space to draw my graph. Of course, if this is paper and pen, you have to erase. Okay, make sure there's more space here. So we have a few options now. It's either like this, this one, this one, this one, this one, or this one, this one. Correct or not? How to tell which is which? Use GC, but of course, let's try to do it manually. Just plot in a few points. So this is x equals negative 3. Sorry, forgot to label. I can sub in x equals to negative 4. How about I sub in x equals to, let's see, 0. Sub in x equals to 0. Then from there, you can figure out the y value. Let's just quickly type it in. What do we get? I get a positive 2. And I get if x is 0, right? So I get a negative 6. Okay? Can? Can, So now, here when x equals to negative 4, if I sub it into this line, I end up with minus 4 minus 3, which is minus 7. So that means there's a point here, which is negative 4, comma negative 7. But I need negative 4, comma positive 2. So is it above negative 7 or below negative 7?
Is above.
Positive 2 is above. So that means, of course, but above x-axis. So you can plot a point here. That means that the graph must look something like the following. Like this. So let's just pretend that the x equals to negative 4 is somewhere closer here. I didn't draw it to scale. So there is my, this point here will be my negative 4, comma 2. That was my, at the bottom there, that was my negative 4, comma negative 7. Okay?
Yeah.
And don't need to label the point. How about the next one? Sub in x equals 0, you get negative 6. So 0, comma negative 6, where is it? This is 0, comma negative 3. So where's negative 6? Above or below?
Is below.
Below. So you always use the asymptote as a reference point. It's like an anchor. Like this is like a reference. Is it above or below the asymptote? Above or below? So it's below, and there's only one option left. This guy is your graph. Okay?
Yeah.
That's how you sketch it. And then of course you can go and sub in y equal to 0 to find your solve for x, and those will be your x and y intercept. Sorry, the x intercepts. Also, you can sub x equal to 0, solve for y, and that will be your y-intercept here. I highlighted for you. I think you can do this on your own. Can?
Okay.
Then don't forget to label the equation. Okay, very good. That is another curve covered. Let's see, next example. This list of examples covers all the permutations of the graph. Oh, okay. Still got one more. Oh my. Let's see. How many more? Let me see. I still got 2 more examples to go through. Okay, can I just go a bit faster?
Sure.
Okay, okay, next one. Next example. Got y equal to x cubed plus 4 divided by x minus 2 times x plus 6. How to draw this graph? Straight away, proper, improper. Power 3 here, power 1, 1 is a 2. 3 over 2. Proper, improper.
It's improper.
Improper fraction. So straight away do long division. But before you do long division, the denominator you need to expand. So x squared minus 2 plus 6 is plus 4x. Minus 2 times 6 is minus 12. That gives you x cubed plus 4 over that guy. So let's just calculate that. Since it's x cubed and then straight away jump to constant, I would like to put in 0x squared plus 0x to make it less confusing. And then plus 4 divided by x squared plus 4x minus 12. Let's see how we can deal with this. Highest degree over highest degree. This guy over that guy. X cubed over x squared, 1x. 1x times into each of them, you get x cubed plus 4x squared minus 12x. Minus bracket bracket. Subtract x cubed minus x cubed gives you 0. Make sure you got a bracket. 0x squared minus positive 4x squared, you get minus 4x squared. Plus 0x minus away negative 12x, minus minus becomes a plus. So you get 0 plus 12, which is 12x. Bring down the 4. Highest degree divided by highest degree. So negative 4x squared divided by x squared, you get negative 4. Take the negative 4, multiply into each of them. You get negative 4x squared. Negative 4 times positive 4 gives you negative 16x. Negative 4 multiply into negative 12, you get positive 48 minus bracket bracket. Minus 4x squared minus a negative becomes a plus. So negative 4 plus 4 is 0, 0x squared. Don't need to put the x squared anymore. Plus 12 minus negative 16 becomes plus 16, so positive 28 x. Plus 4 minus away positive 48, so 4 minus 48 is negative 44. Do we stop here?
No.
Huh? Why?
Stop.
Power 1, power 2. Stop. Don't need to continue already. Finally, we are done, and therefore this is equals to x minus 4 plus 28x minus 44 divided by the divisor, x squared plus 4x minus 12. At this stage, I'm going to replace it with the factored version, x minus 2, x plus 6. Is that okay?
Yeah. Okay.
Not confused, huh?
No.
Good. So asymptotes, tell me.
The x equals to 2, x equals to negative 6, y
And?
equals to x minus 4, x
Well done.
minus 4.
Yep. Okay, sorry. Wrong. Y equals x minus 4, x equals to positive 2, x equals to negative 6. Okay, then we can proceed to draw the graph. Let me just draw it freehand without the aid of an iPad. I'll show you how to do it. Y-axis here, x-axis here. Then I'll draw in x equal to 2, so maybe somewhere here. Draw a few more dotted lines, be more generous. Okay, minus 6, so somewhere here. X equal x minus 4, so maybe negative 4 and positive gradient, so maybe somewhere at the bottom like this. Pass through this point. And then I realize, there is what happens when x equal to 2? 2 minus 4 is negative 2. So should it be above or below the x-axis?
Below.
Be below. So I should make it more obvious by cutting like that. Okay. Then let's think about it. Wow, this one, the graph not so good. You know why? Because there's not enough space here. There could be a possibility that a graph is like this, a graph like this. It's like your, this is like a GC where your scale is not drawn correctly. So what I would do is, on paper and pen, I would erase and then I redraw. Very ugly. When the scale is like that, I already know there's a possibility it could be a curve like that, then I'll redraw. Just redraw, okay? Just redraw. Then maybe I extend the y-axis a bit. I'll put my x-axis closer to there. This doesn't have to be drawn to scale. So negative 6. The point is to make sure you got enough space to show the examiner you know that there's something going on at these different regions. Okay, you don't have to draw to scale. I know this is 2 versus 6. It's not drawn to scale, but it's okay. All right, so now that we have the asymptotes, we can figure out where are the parts of the graph. Can you see clearly that there are 3 divisions here?
Yeah.
Yes, okay, good. Then we proceed to sub in points. So when x equals to, let's say, -10, what do we get? Wow, bunch of numbers. Let's just key it in. I get a -83/4, which is okay. I don't need the fraction. I just need a decimal value, -20.75. Okay. So what can you tell? Where must the graph be? Can you try sketching on the screen? This region. How should the graph look?
Yeah.
Sorry. Very good. Exactly. Okay. So you know that there's a turning point there. You just need to figure out where's the turning point later. Can I skip that step? The finding turning point?
Yeah. Okay.
Just dy by dx equal to 0. Solve for x. Okay. Good. So next step, let's figure out the middle part. What's a good point to sub in? Sub x with?
0.
0. Very good. So 0 here, and we get y equals to, let's see, -1/3. Okay, -1/3. So where is -1/3? Here is y equals, oh, forgot to label, sorry. Y equals to x minus 4, right? So is -4 over here. Where's -1/3? Must be somewhere here, right?
Yeah.
We just plot a point here. Then since there are 2 asymptotes here and there's a asymptote there, actually we can't tell anything. It could curve like this. It could also curve like this, or curve like this, or curve like this. Many possibilities. Here there's a problem, which is that if it's curving like this, right, we don't know whether this is the turning point or not. The turning point could be slightly to the left like this. Can you see? Or it could be slightly to the right like this. The turning point is you really need to dy by dx to find out. Or it could be exactly that point. So after you do this procedure, you will get the answer. Let me just check on my GC now, to save some time. Do you want me to go through the procedure? Do you want me to show you the dy by dx?
Oh, I don't need.
Don't need, okay.
Yeah.
Can. Then let's just, I'm typing in my GC and checking now. Okay, at the end of the day, it turns out to be the following curve. Okay, wait a minute. Let me transfer my x equal to 2 out of the way first. Like this. Okay, it turns out to be this curve. Not happy face, not sad face. Okay. And then there's also a x-intercept. You can solve, okay, sub y equal to 0, solve for x, and then you will be able to find that point. I believe it's a -1.587. Yeah. Yes, you can work it out yourself. Then for the last part, if you just sub in maybe x equal to 3, then you'll be able to get a y value. It happens to be, let's see, x equal to 3, and I get the intersection to be 3.4. So it's 3.4, which is above or below?
Above.
Above. Okay. So because when x equal to 3, this is 3 minus 4, which is -1. Right. So that means that my graph is also. Wait a minute. Let me check the graph first. Y equal x minus 4. Yeah, my graph is not that accurate. Okay, hold on. Let me just make a slight adjustment to my x minus 4 graph. So it will cut here like this. Okay, the intersection is over here, which is at 4,0. You can work it out yourself. Then your the 3,3.4 means it's somewhere over here, and it's actually slightly towards the left of the turning point. The turning point happens to be 3.46, 3.289.
Oh.
So we can just draw the curve like this. Okay, there's a point here. That's a turning point. Turning point 3.46. I call it a turning point because it turns, right? It goes down and then it goes up, so it turns around. 3.289. Yeah, then this guy that I was talking about, the 3,3.44 is over here. 3,3.444. Okay, you don't have to label this point. Maybe I should just label in red color to tell you it's not required. Okay, and are we done? Yeah, we're done. Okay, you got the intercepts. You got the y, the x and y intercepts. X intercepts are here. Y intercept is there. You have your vertical asymptotes labeled already. You have your diagonal asymptote labeled here. Maybe you should bring it closer towards a line. And oh, sorry, not done. Need to copy the equation right down over here. You can use the original format or the updated format. Both are fine. Perhaps safer to use the original format. So in case you make any mistake, right, you can just make sure it's correct by copying the original format, the original question. And then you also label the turning points. I'll just label the turning point here. It happens to be, let's see, negative 11.17, comma, negative 20.41. Okay, that's this graph. Can I move on?
Yeah.
Okay, last example. We have negative x squared plus 4 over x minus 3 times x plus 3. Okay, let's see. This is the graph of okay, proper, improper?
Improper.
Improper. Oh, sorry. This should be a plus 3. Okay, let's see. So improper straight away, we have to do long division. But what do you have to do first? Before you do long division?
Expand.
Expand, negative x squared plus 4 divided by. I hope you remember a minus b times a plus b is a squared minus b squared. So x squared minus 9. Okay?
Yeah.
Can I show you a special trick without long division? Whenever the degree is the same, here's a trick you could do. I need to make sure if you do the long division, you end up with negative x squared divided by x squared. So straight away at the first answer, what is this value here?
Negative 1.
Negative 1. So you're expecting a negative 1 at the end of the day, right? Negative 1 plus da, 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 da. Right? So with that in mind, there's a shortcut we can take. There's a shortcut which is the following. Do you agree that the minus x squared plus 4, I will just write it at the side. It's actually the same as negative times of x squared minus 9, but you add on some constant. Can you see that? Could this be possible? Can you solve for k?
10.
Can, right? Let's see what happens. Let's see what happens if I expand this out. This one is question mark. Expand out. I get negative x squared plus 9 plus k, right? But it's minus x squared plus 4. Maybe I'll just copy it down a few times. Then what do you think is k? Got minus x squared can cancel away. You got plus 4 equals to plus 9 plus k. What's k?
So it's minus 5.
Minus 5. Why did I purposely write it in this format? Such a funny format. Because now I can substitute in the numerator with minus x squared, minus bracket x squared minus 9 plus k, which is a negative 5, all divided by x squared minus 9. Let me ask you a question. Minus 5 minus 11 over 7. Do you agree that it's minus 5 over 7 minus 11 over 7?
Yeah.
So you can do the same thing. Instead of 5, 11, 7, it's this guy, that guy, and that guy. Maybe I don't change. I use a different number. 8. Okay? So we're going to do the same thing. So minus x squared minus 9 over x squared minus 9 minus 5 over x squared minus 9. Did you see that?
Yeah,
What happens over here?
can split up. Oh, then it cancel out.
You're left with
Negative 1.
minus 5 over x squared minus 9. If you practice this long enough, you can actually do this inside your head. Can figure out that k is negative 5. Then you avoided long division. Is that useful? I don't know lah. Up to you.
Will
Well,
it
I'll just
always
show you.
work?
No, it only works when the degree is the same. Only when the degree is the same. Okay.
Okay.
So yeah, limited applicability. Long division is your best friend, but long-winded. Long-winded best friend is long division. So this is just a shortcut. Provided you know how to do it. Forget it if you don't understand. Okay, don't worry about it. Just long division. The long cut, the direct path is long division, which you should already learn from Amex, right?
Yeah.
Okay, moving on. So now that we have this graph, I mean this equation, tell me the asymptotes. Maybe I rewrite it.
Equals to negative 1.
This is x plus 3, x minus 3. Y equals negative 1. Very good. What else? 2 more.
X equals to negative 3 and x equals to 3.
Very good. Then we can proceed to draw the graph. So I probably should have more space. Okay, then negative 1, right? Then just the same procedure again. What's the procedure? Choose a few good values of x. So usually you pick a value that's like slightly less than negative 3, something that's in between, so maybe 0. And then finally sub x equals to a value that's bigger than negative 3. How about sorry, this should be positive 3. Something is, yeah, sorry, positive 3. Something bigger than 3, which is maybe 4. Okay?
Yeah.
For the sake of saving time, I'll just give you the answer. Okay. This is, what is it? Let me see first. -1 minus 5 divided by x squared minus 9. At the end of the day, your graph will look like this. This is supposed to be a horizontal line, y equal to 3, y equal to negative 1. So you look something like this. No special tricks, it's just symmetrical. About. Oh wait, the special trick here is that it is symmetrical. There's no turning points. There's no go up and then go back down. Don't have.
Oh.
Okay. You can verify that by differentiating get dy dx equate to 0 and solve for x. You realize that there is only one turning point, which is this fellow here. Okay.
Okay.
Yeah. Then just label the equation, and that's it for the recap. Back to the main program, which is your EJC tutorial. Okay. Can label the intercepts. You figure that out on your own. Dot. Okay.
Yeah.
Okay, next. Okay, so this one's question, is it 6? Or B power? What question is this already? Oh no, where did I last stop? Question 4. Oh, sorry, question 4. Question 4A is correct. 4B is not correct. What happened? 4B, this is x equals to t squared. You must label. Oh, right, you labeled here. Good. That's not correct. Do you know how to use the parametric function on the GC?
Yeah. But I got that though.
Here you have to be careful. I believe you didn't set the domain of the t minimum, t maximum correctly. Okay, let me show you. I'll just use a physical GC because it's a bit faster. Okay, so here is the GC. You are supposed to go to your home page. Then you go to mode, go down, function, parametric, polar, sequential. Select parametric, press enter, and go back to y equals. You get x1t, y1t. So you're supposed to key in whatever they gave you, which is x equal t squared. So variable here, t power 2. Y is 2t, so 2 times variable. Press enter. Right? Hopefully it's clear. Yeah, what else? You got t squared over 2t. Let me increase the brightness. Okay, so yeah, then you can proceed to graph. But before you graph, press the window. Here you notice t min to t max. 6.28 is actually 2 pi, by the way. Now, take note that if you look at question 4b, they mentioned that t element of all real numbers are the set of all real numbers. T element of the blackboard board R. The bubble letter. Here, t element of R. Okay. So yeah, anyways, you have to consider negative values of t as well. So how about if we put -5 to +5? Balance. Step size don't care. It's okay to change it. Doesn't matter. You can always reset it when you press window and zoom and then Z standard. Z standard will go back to normal. Then just change it to -5 to +5 manually, please. And then press graph. There you go. I believe what you did was you set it at 0. You didn't change the Y, so it's still the original 2 pi. All right, then you press graph. You only get the top half. Is that what you did? I suspect that's what you did.
Yeah, I think so.
Okay, a bit blur, is it?
Can see.
Okay, so do you want me to show on the digital calculator?
No, I can see.
Can see, okay, just make sure you change the what do you call that? Why is it not showing? What happened? Oh, sorry, let me go back to my notability first. Yeah, so anyways, yeah, you're missing the left half, the bottom half. Okay, that's all. Is that okay?
Yeah.
Yeah, just include the bottom half. How about part C? Something is wrong. There should be an empty circle here. Here, pay attention. They told you 0 less than equal t, strictly less than pi over 2. They're being very tricky. Can you include the value, the point where t equals to pi over 2? Can or cannot?
Cannot.
Which means that over here, when t equals pi over 2, if you sub it in, you'll end up with x equals to sine cube of pi over 2 and y equals to cosine square of pi over 2. You will soon realize that it's actually just 0, 1, right? Use a calculator. Then you realize that this should be an empty circle.
Oh.
Has to be empty circle. Very important. This one solid, that one empty. This is especially important when you're doing the functions kind of question. Okay.
So the 0 is the 0, 1 is the empty.
Yes, correct.
But I follow the domain, no?
Yeah, the domain. Here you have to be careful. From 0, as it increases from 0 to pi over 2, the graph actually goes in this direction. This is the point when t equals to 0. That is the point when t equals pi over 2. That is the point when t is, let's say, pi over 2 is like 1.57. So maybe this is t equal to 1. 1.2. Let me show you on the GC. If you slow down the GC, you'll see the animation going on as you increase the value of t. Let me just share the calculator first. Can you see the calculator?
Yeah.
Okay, good. So what you're supposed to do, press mode, go down, down, select parametric, press enter, go back to y equals, key in the function. X is sine cube, right? So where's my sine? Over here. Sine x, close the bracket, then power 3. Power 3. For the y, it's cosine square. So cosine x, close the bracket, power 2. Okay. You can draw the graph. But wait, sorry, you need to change the scale of the t minimum and t maximum, the range of the parameter. 0 to pi over 2. So maybe I'll just key in pi here divided by 2. Okay, press enter, it will calculate the decimals. 0 to pi over 2, clear?
Yeah.
Now I'm gonna change the speed of my calculator a bit. I'm gonna purposely make it super slow, 25% speed. Okay. Now I show you the graph. Stand by. I'm gonna press the graph button. Maybe I also change the scale. Oops, sorry. Okay, that's going a bit too slowly. I'm gonna change the scale to the relevant part, which is from -1 to +1, and the y scale is from -0.2 to +1.2. Okay, then I draw the graph and I show you the animation. Stand by. It's gonna slowly grow from the right towards the left. Let me slow down the speed of the calculator and show you. Okay, it's going very slowly. You see the blinking speed is super slow. Press the graph. Wait a minute. Oh, did I calculate? Did I do wrongly? Do you see the animation just now?
Yeah.
It went. Oh, sorry. Did I get it wrong? Let me double check first. Hold on. Did I calculate wrongly? Let me see. Let me think. Wait a minute. Hold on. I understand now. Sorry, I got mixed up. Sorry, I made a mistake here. Specifically, the x and y, I read it wrongly. Sorry, I read the question wrongly. Over here, it should have been the other way around, right? X equals to cosine square and y equals to sine cube. Yeah, you wrote down y equals. I think maybe that's why you got confused. Okay. This is x equals cosine square t and y equals sine cube, right?
Yeah.
Okay, so sorry. Let me try again. The graph should grow this direction if I now just swap it around. Let me just swap it around. Oh my, let me just. What was it again? This is x equals to cosine square. That should be the correct one. So cosine x, close the bracket, then power 2. After that, you get sine x, close the bracket, and raise to the power of 3. Okay, and now I'm gonna slow down the calculator. Then we draw the graph. Take a look. The graph should go downwards. Okay, from the top left corner, it will go. Sorry. No, it should. Let me think properly. Sorry, it should go from the right towards the left, from the bottom right to the top left corner. Okay, take a look at the animation now. You see that? Yes, it goes from the bottom right to the top left. So that means, what does that mean? It means that this graph is plotting points from t equal to 0. If you press trace button, you see, you can. Oh, how do I press trace? Okay. Yeah. So you see, when I press left, the t value will get smaller. When I press right, the t value will get bigger. And you also notice that the cursor is moving upwards, right? This is when t equals near 0 at 0. This is when it's when it's 0.13, when it's 0.26, 0.39, and slowly increase the t value. You realize that eventually you will reach pi over 2, which is at 0.1. This one e power -20 means times 10 power -20, which is essentially 0, 0.1. Is it clear? Do you catch that? You press the left. So what happens? You see, when I look at my mouse, I'm pressing the right button one time, click one time, click one time, click one time. The t is slowly increasing, right? If the GC do it for you, you sub in different values of t and you calculate the x, calculate the y. Cosine t square for the x, sine t cube for the y. And then you realize that the x and y is slowly changing. And the pattern is that it is slowly increasing from the bottom right to the top left corner. Okay? Hello?
Yeah.
Sorry, so I haven't answered my question. So when t equals to pi over 2, what is the corresponding x coordinate, y coordinate?
Is 4.21,
Huh?
1.
Sorry, say again.
Wait, is 0, 1?
Yes, 0, 1. Sorry, oh my goodness, oh boy, that is not good. What happened to my laptop? It just died on me. I think it overheated. Oh my goodness. Sorry, give me a while to reset my
Okay,
laptop.
sure.
Oh my god. I think it's overheated. Okay, that's not good. Oh my, that's not good. Sorry,
Okay.
Oh, that's not good. That is very bad. Why is my fan? Okay. Eh? Wait a minute. Sorry, give me a second. I need to go and check something.
Okay.
5-minute break. 5-minute break.
Okay.
What time do you need to leave?
Like 1.
Okay, can same. Good. Sorry, 5-minute break. I'll be back soon.
Okay.
Oh yeah.
Mic test, mic test. Mic test, mic test.
Yeah.
Am I connected? Sorry, my house just short circuited the electricity. I had to go and fix it.
Oh, oh my. Okay.
Yeah, my Wi-Fi is okay. My Wi-Fi is up again. Let me continue. Okay, what was I saying? Let me share screen first. Wait. Yeah. Okay. Okay, give me a minute. Give me a minute.
Okay.
Circle. Okay. Exclude t equal to pi over 2, which means you exclude this point 0, 1. Clear?
Yeah.
Yeah, just an empty circle. Okay, moving on. Question 5, part 1. ATQ. What is ATQ? Answer the question. Here, the question is asking you to give the coordinates, right?
Yeah.
Read the question. So here you did not give the coordinates. You are answering near. You're supposed to give 2, 0. Okay, 2, 0. That's the answer. 1 mark question. You don't answer the question, they are not going to give the marks. You give x equal to 2, that's not the coordinates. Okay, not precise enough. Can?
Okay.
2, 0. Don't just give x equal to 2. No. Part 2 is fine, the asymptotes. Then part 3, here you have to be a bit careful. So for question 5, part 3, what are they asking? They are asking you to sketch rationale. Sorry. No, they're asking you prove using algebraic method that 3x minus 6 over x times x plus 6 cannot lie between two certain values. And you realize that, it's the same question as what I gave you just now. Okay, so the key here is that when we say cannot lie between now, what you're supposed to do is to, you can let y equal to k, but I don't think that's necessary. What you're supposed to do is to just do what you did here. Good. Just rewrite it as y, rewrite the equation so it becomes flattened. Flattened meaning you just multiply denominator over to left hand side. So you get y times x plus 6 equal 3x minus 6. Then multiply throughout and you get a quadratic. And then you realize, it's a quadratic in terms of x. Pretend the y is a constant. Then you just need to use b squared minus 4ac. You have to treat the b squared minus 4ac as the discriminant. Sorry, it is the discriminant. And you have to consider the case where it's less than 0 so that there is no solution to y, not more than 0, okay? Less than 0 means no real solution. There's a complex solution involving I, a plus bi, but you don't want real solution. So you have to set the triangle being the b squared minus 4ac. It's called delta, it's a Greek letter, to be less than 0, okay? So it shouldn't be more than 0, it should be less than 0.
Oh.
Yeah. So anyways, at the end of the day, you should get if I am not mistaken, this is correct, just have to change it to less than 0. Change this to less than 0. And then yeah, at the end of the day, let me check your working first. Yeah, this is correct. So you get 36y squared minus 60y plus 9 less than 0. Okay, I'll just change everything to less than. Very good. But you can actually solve this equation, right? Do you know how to solve a quadratic inequality? You're supposed to factorize. Okay, you are able to factorize this eventually as 6y minus 1 times 2y minus 3 bracket.
But I key in become like imaginary number. Or yeah, key wrongly.
You probably keyed in wrongly. Positive 36, negative 60, positive 9. All right. Actually, you could divide by 3 first before you get this answer. 12y squared divide by 3. So negative 20y divide by 3, you get positive 3 less than 0. Okay.
Okay.
Then factorize. So now you get a quadratic, positive 6 and positive 2. So that means it's a happy face. So draw happy face, draw the y-axis. There are 2 roots. There namely 1 over 6 and 3 over 2. So you want this to be less than 0. So it's the bottom part here. So that means it's 1 over 6 less than y less than 3 over 2. That's your answer. Okay, actually, this answer can also be found directly from the graph. Do you know how? Let's
No.
take a look at the function 3x minus 6 over x times x plus 6. 3x minus 6 over x times x plus 6. Where did I? Remember I went through this already, right? Let me find it first. There we go. Haha, the example just now. Okay, it's from the EJC. So this is the graph, and hopefully you realize that there's a maximum point 1 over 6. There's a minimum point here. This guy, okay, I can't remember what's the point. Let me see. It is a negative 2 comma 3 over 2 lah. So you can see that there's a dotted line, horizontal line here, and there that passes through. Such that there's a gap in between, right?
Yeah.
You see? Then you should realize that this is y equals to 1 over 6. That is y equals to 3 over 2. So that's why the answer is 1 over 6 less than y less than 3 over 2. This is the region that is banned, where there are no y's allowed. Okay?
Oh.
Yeah. From the graph, you can see using a GC. But algebraic method, that's what the question requested from you. So you will need to use the quadratic idea. Where was the question again? Yeah. Okay, disappear. Where? Right, here. Oh, this is question 5, part 3. Okay, then for part 4, I already answered the question. 5 part 4 asks you to draw the graph. We already did it just now. Okay?
Yeah.
Can okay, can. Moving on to question 6. We got question 6 over here. Here, just be careful your notation. Don't make the negative root 3 and the 0, negative 1 clash. Your 1 look, I cannot see the negative sign. Should be a negative 1. Okay?
Oh, okay.
Just write it clearly. Sketch the curve stating exact coordinates of any point of intersection. Okay, done. Part 2, show algebraically the x coordinates. Okay, that's fine. Then part 3, use your calculator to find these x. Oh yeah, your answer was correct. Okay, don't need to go through. Good. Question 7. Part 1, obtain the equations of the asymptotes. Okay, so you see, this is starting to become more complicated where they start to introduce a letter A inside our equation. So that's why you have to learn how to do the graph sketching manually. Okay, don't just rely on a GC. You must know the procedure, which is to look at the degree first. This is power 2 over power 1, so straight away long division. Your answer is fine. But the more important thing is you must now identify who's your asymptotes. Okay, so yeah, you identified correctly. Okay, part 1 is fine. How about part 2? Find dy dx. Okay, over here, which one do you think is this is y equals which one do you think is easier to differentiate? The long division, after the answer you get after long division, or the original format?
After long division.
After long division, right? Clearly, this is easier to differentiate. If you wanted to use the original format, right, you can, but you need to use quotient rule. I think that's what you tried to do, but you did it wrongly. Low D high, less high D low. Do you get this? Do you want to take a look? Check. Anything confusing? Compare.
Oh.
Supposed to have 2 terms at top. Low
I think I
bottom D
forgot.
top minus top D bottom, right?
Yeah.
So quotient rule used wrongly. Must go and revise your differentiation technique. Okay. Yeah, so that's from Amex. Anyways, now we just try with this is very long-winded, so I will skip that. Instead, I'll use the updated format, which is the x plus negative 3a squared over x plus 2a. Now, if we differentiate this, dy by dx will give me what? Differentiate x, you get 1. Differentiate this one. Now take note that the 3a squared and 2a is just constants, so it's essentially 1 over x. How to differentiate 1 over x? Just treat it as x power -1, then bring down o power -1 to get the new. Don't give me ln x. We are not integrating here. Differentiation. So -1, x power -2. If I simplify, it's just -1 over x squared. But of course, it's not x squared, right? It's x plus 2a squared.
Yeah.
But wait, chain rule. Do I need to differentiate the 3a squared so I get negative? So -3 times 2 times a? Wrong. What's wrong?
A is a constant.
A is a constant, so you leave it alone. Leave the -3 as a squared alone. So you simply multiply by -3a squared. And the chain rule that you're doing is you're differentiating the x plus 2a. What's the derivative of x plus 2a with respect to x? 2 times 1 plus 0. Differentiate x, you get a 1. Differentiate 2a, you get a 0. Plus sign, copy and paste. Okay, so times 1 now, then you don't need to do. How about if this was a 2x? Then over here it will be a 2. Okay, chain rule. Is that clear?
Yeah.
If this was 7, then this will be 7. Okay, chain rule. But here, because it's a 1, you can ignore it. Now simplify this and you get 1 minus minus become plus, so positive 3a squared. Right, negative times negative gives you positive over x plus 2a bracket square. Clear? Good. Then deduce that C has no stationary points. Then you can say for SP, that's my favorite phrase, for SP, for stationary point, the most efficient way to write it already. For SP, dy dx equals 0. Then you just need to copy and paste this expression equal to 0. Then you solve for x. So 3a squared over x plus 2a bracket square equals to -1. Flip it upside down, you get x plus 2a bracket square over 3a squared equals to -1. Because you flip around, -1 is still -1. X plus 2a bracket square, make it the subject, multiply by 3a squared. Then you just take a square root. So x plus 2a, you realize a problem. What's the problem? Here we said that a is a negative constant, so it's less than 0. What's a squared now? It's positive, right?
Yeah.
Then what's negative 3a squared now? Positive or negative? Times -3.
It is positive.
0. What happens when you times negative to the inequality direction?
It becomes less than 0.
Less than. So your answer, can you answer me again? Is this positive or negative?
Negative.
Less than 0 means negative. Okay, so -3a squared is negative. Here, when you want to go from square to square, you have to take square root. So if you take the square root of -3a squared, then you plus minus. Is this correct? Yes, but there's a problem. We are dealing with real numbers here. If this guy is what again? Negative. Can you take square root of negative?
Cannot.
At least in the real numbers, no lah. This is not complex number topic, so no, cannot. So this is not real. So maybe you can say not an element of real numbers. Not real. Don't need so complicated. So is not real. So therefore, no solution. Which means no turning points, no stationary points. SP means stationary point, TP means turning point. They are equivalent. Essentially. There's stationary point of inflection, but let's not go there. So no stationary point, okay? To answer the question.
Okay.
Now for drawing a sketch and label coordinates, this one have to be a bit careful. Here they purposely tell you A is less than 0 so that you can draw the graph. So let's think about it, how to draw the graph. This is definitely a wrong graph to draw because your asymptote is x equals to -2a. Oh wait, actually your graph might be correct. Oh, actually it's correct. Sorry. But the direction is wrong. It should be this curve and that curve. Your asymptote is actually correct. -2a should be on the right of the y-axis. This is very good because it's more than 0. A is less than 0, so 2a is still less than 0 because we multiply by +2 on both sides. Direction don't need to change. But if it's -2a, you need to flip the direction. Okay, this one is times 2, this one times -1. Also positive, very good. Your your, what do you call it? Asymptote is fine. But then the graph is wrong. Because if you just plot a few points, okay, how do you draw a graph? I went through many examples with you already. You just have to sub in x equals to this region's x and that region's x value. Here is minus 2a. So what's a value that's smaller than minus 2a? How about 0? Can we have that?
Can.
Can. So sub in x equal to 0. When x equal to 0, what's the y? Maybe we just use this format. Okay, 0 plus negative 3a squared divided by 0 plus 2a. Is that okay? You see, we're doing the same procedure, it's just that this time there's an a. Can?
Can.
Now simplify, you end up with a minus 3a squared over 2a. So it's negative 3 over 2. A squared over a is just a. So negative 3 over 2a. Think about it. A is less than 0. So negative 3 over 2 multiplied by a. Is it more than 0 or less than 0? Times negative 3 over 2 to 0, of course, is still 0. But what's the direction now? Negative sign times negative
more than 0.
More than 0. So that means that you have to pass through 0 comma negative 3 over 2a, and this being positive. So where can it be? Option 1, option 2, option 3. Where is 0 comma negative 3 over 2a? Option 1, 2, or 3?
The first one.
Above origin, at the origin, or below? Option 1, exactly. So that means there's only one correct answer. It has to pass through 0 comma negative 3 over 2a. Now tell me, does your graph, are you convinced now that your answer is wrong? Your graph need to pass through this point. Does your graph pass through that 0 comma negative 3 over 2a?
No.
No, so confirm wrong, right? Is it clear now? Then you have to draw a graph that will have these guys as the asymptote and will pass through that point. There's only one possibility. Can you draw the graph? Sketch.
But it will pass through another point though, no?
Yeah. Yes, and then we can find that point later. But your graph a bit off. The link a bit off. You must go. You must go closer towards it. Okay, so maybe something like this.
Yeah.
Yes, exactly. Good. Wait. Actually, how do you know that it will pass through this point? You do, how do you know it's below y equal x? What's the procedure? Not because I tell you the answer. What's the procedure during exam?
You mean this one?
Yes, correct. How do you deduce that it is this graph? You cannot type inside the GC and A is A. You cannot type A in the GC.
Because the other side is symmetrical.
Wrong. No, that's not the answer. It could be possible that you have this as a graph.
Huh?
Yes, it's possible. It still passed the vertical line test. It's just that I haven't give you examples for this. Okay? It's not because symmetrical. No. What's the procedure? So far, all the examples.
Can sub in the value.
Sub in a value, a good value of x. In this case, what value of x do you think? What was the rule for that value of x that you must sub in this time?
It must be more than x equals to negative 2a.
More than negative 2a. To the left of negative 2a means less than negative 2a. To the right means more than negative 2a. So how about, let's say, I don't know, let me think. Can we put in a? Right? Positive 1a is bigger than negative 2a, right?
Cannot, because
Wrong.
the a is negative.
Very smart, very good. Yes, because the a is negative, if you put in positive a, it becomes negative, which is smaller. So you actually need to come up with something like negative 3a, for example. Okay, so let's just sub in with x equal negative 3a. Okay. Then we can get the corresponding y value to be, I'll just use the original here. So we get minus 3a plus minus 3a squared divided by minus 3a plus 2a. I'll just get rid of this cross. This is wrong. Simplify, you get what? Minus 3a alone, minus 3a squared over minus 3 plus 2 is minus 1a. Minus 3a squared. Minus become a plus. A squared over a gives you a. So it's positive 3a. Minus 3a plus 3a. What a coincidence, it's 0. Purely coincidental. Okay, purely coincidental. So it passed through negative 3a comma 0. It could be positive, could be negative, but it doesn't matter, right? Because once you know okay, you know what? Just for the purpose of demonstration, let's just sub in with negative 4a instead. Okay,
Okay.
let's try that as well. To be more generic, because it's a coincidence that it's a 0. I want to bring up a bigger point, which is that you don't need the 0. If it's negative 4a this time, you can plus negative 3a squared divided by minus 4a plus 2a is just, I'll just write it in, is something that can be simplified. Let's see, negative 3a squared on top divided by minus 4 plus 2 is negative 2a. So minus 4a, minus minus become a plus, 3 over 2 a squared over a. So 3 over 2 a. Minus 4 plus 3 over 2 is negative 5 over 2 a. Now, negative 5 over 2a is essentially negative 2.5a. So is this positive or negative?
A
is negative. So negative 2.5a becomes
positive.
positive, more than 0. So where's the point? It's somewhere here. This is a point, what is it? Negative 4a comma negative 2.5a. Is that okay?
Yeah.
Good. So that means your graph, but then it's negative, but it's positive, but could it be above or below the x, the y equal to x? Could it be here? Then maybe your graph is correct. Or could it be touching the asymptote? Or could it be below the asymptote? How do you tell? Option 1, option 2, option 3. The correct answer is option 3, but why?
Can I sub in again, right?
Sub in, you can sub in again, but you have to be
I don't
strategic.
know what to sub in though.
Look carefully. I drew it purposely as a vertical line. Vertical line equation is it passes through negative 4a comma negative 2.5a. Vertical line is x equals, right?
X equals to
What's me?
negative 4a.
And do you see two graphs that are two curves that are intersecting? Your answer, pretend you didn't draw this. This is the wrong answer. So there's a vertical line, there's an asymptote. Can you find out the coordinates of point 2?
Can.
Of course, you just have to sub in. That's the equation. Sub in.
Oh, so y equals to negative 4a.
So that means that the coordinates of this point 2 is actually what? Negative 4a comma negative 4a. So now tell me, the pink color point, should it be, the negative 4a comma negative 2.5a, which belongs to the original function fx, y equal f of x. Should it be option 1, option 2, option 3? Definitely not option 2, right? Because it's different, minus 2.5 versus negative 4. So is it above or below? Think carefully.
Below.
Why? Negative 2.5 is smaller than negative 4a.
Yeah.
Negative 2.5a is smaller than negative 4a. The reason is, if you do inequalities carefully, negative 4 is less than negative 2.5. A is negative. So if you multiply by a on both sides, a is negative. What happens to your direction of the arrow?
It change direction.
Very good. So it's more than. That means negative 4 is bigger, right? So negative 4 is bigger means it should be above the negative 2.5.
Yeah.
Is it clear now? Super clear?
Yeah.
So that means your graph must pass through negative 4a, negative 2.5a, and it is option 3, below 0.2. Then from there, you know that you must draw the graph as whatever you have drawn there. Okay?
Yeah.
There's only one correct option. That's how you do it. You have to sub in manually. That's why I go through all the examples just now without the a, so that you get used to the procedure. Okay? Sub in with a value less than the vertical asymptote, sub in with a value more than vertical asymptote. Then check, should it be above, should it be below, so on and so forth. Then also you can find out the x-intercepts and y-intercepts, sub in x equal to 0 to get the y-intercept, sub in y equal to 0 to get the x-intercept. Okay? You will eventually get this point here, which is a minus 3a comma 0. And that point there, which is something comma 0. I believe it's positive. Sorry, it's positive a, which is a negative value. Positive
yeah.
a, which is a negative value, right? A is less than 0. Okay, this is a comma 0, that's minus 3a comma 0. Can?
Okay.
A bit confusing, because a is less than 0. I hope you are still clear.
Yeah, still okay.
Can, yeah, so this is the common trick you must know. Use the asymptote as a reference. Okay, that's part 4. Moving on. Question 8. Find the values of ABC. So did you get that? I think you made a mistake over here when you are doing differentiation. This time you did the quotient rule correctly. However, when you are substituting, you sub wrongly, I think.
Oh.
Okay, here you should be scratching it off. Please scratch it away cleanly. Okay. Then when you sub it, then also your A, okay, maybe the scanner got problem, huh? Or is it your pen ink? Yeah, you didn't close the loop. It's an A, it's an A. It's an A. So when you sub in x with -4 and x with -4, you should get a minus 16 plus 2a over here, and not minus 2a. I'm not sure how you got this minus 2a. Very confusing. Right?
Oh.
This part, sub in -4, you get minus 16 plus 2a. Right? I showed the working over here.
Yeah.
Correct, right? Minus 16 plus 2a. So yeah, something went wrong, huh? Let's just take a look at the solution. Okay, no, I just work it out. Okay, this guy means that dy by dx equal to 0. That's what you could do to get an equation in terms of a and b. You will get the equation, but not the most efficient way, because you could have just directly sub in -4, 2 into the equation of the straight line itself without finding the derivative. Right? Oh yeah, how come you squeeze it over here? Just write down y equals. Very important. Use it as a reference so that when you differentiate, you will know what is the top, what is the bottom. Just write it down. Just copy the equation. Very important.
Okay.
The highlight is the star of the show. Just draw it at the front. Don't just jump straight to dy dx. Okay, so what you could do is to sub the -4, 2 directly into y. So you end up with 2 equals to x replaced with -4 -2 minus -4, right? Simplify, blah, blah, blah. Eventually, you'll be able to get a -4a plus b equals to -12. Do you want me to show the working?
Don't.
Don't need, Okay, then that's your equation 1. Then after that, what you can do next is you can sub in with the other point. Sub in with the other point, which is, what's the other point? Read the question.
The 0, -6.
0, -6 into y. Don't need to differentiate. Don't need to differentiate here. So -6 equals to x is 0, so 0 squared plus a times 0 is 0 minus, plus b divided by c minus 0, which is just c. So, but wait, we already found out the value of c, right? Which is -2. Well done, good. So you sub in the c directly with a -2, which you found. Solving, you get b equals to, what is it? 12, right? Correct?
Yep.
Bring over -6 times -2 is positive 12. Then if you know b is 12, you can sub in over here. Okay, I call this equation 2. Then sub 2 into 1. Blah, blah, blah. Eventually, you'll get a equals to 6. Is that okay? Do you need me to show the working for this one?
Don't need.
Don't need, Okay, can. So yeah, you get a and b already. Done. This one hopefully is 3 marks. You should be able to get this one. Here, the trick is turning point. You must learn to filter out the turning. Forget it. Part 1 is easy. Don't bother with turning point. Just know that it is a point that lies on the graph, so you can just use the graph directly. No need for dy by dx. It will work, but you see it's more prone to careless mistakes, right? It will work, but you're more prone to careless mistakes. Equate to 0, solve. Anyways, moving on. And also, actually, it's not enough, because you'll get an equation involving a and b. So you still need another equation. And that means you need to sub in again with another point 0, -6, which is what you are trying to do, but yeah, you made a mistake with the substitution, that's why. Okay, I don't talk too much about it. Moving on to part 2, sketch the graph. So here, okay, no space. All right, let me see the timer, 12:54. Oh, that's no good. Okay, I will. Okay, sketch the graph, right? I'm just gonna change to the solution now. Can you see the shared screen? This one?
Yeah.
Okay, so ignore the circle first. Just the curve at the top and the bottom. That's how you draw the curve. I don't go through how to draw it. Is that okay? Because you can just use a GC now. Use a maximum point, minimum point to find out the coordinates of the starting point, as well as I'm sure you know that this is a degree 2, degree 1, so you have to do long division. Then you'll get your quotient plus remainder over divisor. Then you are able to identify your asymptotes, right? X equal -2 and y equal -x minus 4.
Yeah.
Don't need to go through, right? Okay. Then x-intercept, y-intercept, you just a coincidence over here that the 0, -6 happens to also be the turning point as well as the y-intercept. Okay, use a GC and you'll verify that to be true. Can? Then here, y got circle. That's not relevant to part 2 anymore. That's part 3. Let's take a look at part 3. This one very special. By drawing an appropriate graph on a sketch of C, find the range of values of k more than 0 such that the equation blah 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 equal to k squared has no real roots. So what you should realize straight away is that this is the equation of a circle. Can you see? X plus 4 bracket square plus y square equal to k square. But it's just that the y got replaced with this fella here.
Yeah.
So that means that this is just the equation of a circle and the equation of this weird graph, rationale function, and you solve it simultaneously. So you sub in the y with the x squared plus ax plus b over c minus x. Okay? Right?
Oh.
So this is equation of a circle with center -4 because x plus 4 equates to 0. You solve for x, you get -4. And the y, this entire thing is y, so it's y minus 0. So the y coordinate of the center is 0, and the radius is k. So that's why you draw a circle with radius k. All right? Now, when you want to solve for the equation simultaneously, you can sub in y with this guy. But that is equivalent to drawing the graph of both of those functions and finding the point of intersection. So here, the solution, they strategically drew a circle that's centered at -4, 0, right? Because it's x plus 4 bracket square and the y square. Like over here, here's the working. X minus -4 plus y square.
Yeah.
Then the center is -4, 0, right? And the radius of k. So you can imagine how the graph would look. Let me just demonstrate on Desmos. Wait a minute. Let me show you. Give me a second. Share screen on Desmos. Okay, so here is the. Okay, don't worry about the Desmos. This is just a more efficient way of typing in a function. This is what? X squared plus 6x plus 12 over -2 negative x. Right? So, yeah. You can always use a GC for this, but I have a more powerful graphing calculator, so I'll just use it for demonstration purpose for the sake of time. What was it again? X squared plus 6x and then plus 12. You close the bracket first. No, let me change the coefficient. 6x plus 12. Then you divide it by. Oh no. What is it? -2 minus x. Right, this is the graph. Can you see? Then you want to draw a circle center at -4, 0, right? And just coincidentally, the turning point there is -4, 2. Can you see?
Yeah.
-4, 2. This one. Okay, so we're gonna draw a circle this time. Make it a bit bigger. Hopefully you can see better. Then -4, 0. So the equation of a circle, x minus 4 square plus y square equals to k squared. Now I know this on a GC you cannot do that, but here we can add a slider, you see. Right? Sorry, x plus 4, sorry. So it's centered at 0. You see, what I can do here is I can change the k, and my circle can grow. Can you see that?
Yeah.
Okay, so let's just go from 0 to 10. Then you can see the circle can grow to different sizes, right? Now
Yeah.
the question is asking you, what's the max? When you want to have no solution to this equation, it means there's no intersection between the circle and the curve. Does this work? Does this picture satisfy the condition? There's no solution,
Yes.
i.e. the graph has no solution, no intersection. Yes, right? When the
Yep.
k equal 1.2, which is the radius essentially, right? K square is a radius square. If I increase it a bit more, does it work? 1.6?
Still works.
When it's here, 2.6, does it work?
No.
No, it doesn't, because it intersects 2 times, here and here. So that means you must find a sweet spot over here. When it touches it, there's only one point of intersection. Okay. Here, okay, it still doesn't intersect. Negative 4, 1.9, and the other point is a negative 4, 2. Still haven't touched. Is it clear?
Yeah.
So if you increase it a bit more, if eventually it reaches 2, you realize that they are tangential to each other, touch each other at one point. Is this allowed? Remember, no solution means no intersection.
So cannot also.
So this cannot as well. So k equal 2 is not allowed. If k is now 2.001, if you zoom in far enough, you'll realize that they do intersect here and here. Can you see?
So still cannot.
So cannot. The moment the k exceeds a certain value, it's not allowed. What's that value?
2.
2.001 cannot. 2 also cannot. So that means it's 2 lah. If it's 1.99, 1.99, you realize if you zoom in far enough, oh, there's still a gap. So safe. We are still safe when it's 1.99. 1.999. Well, it seems it's intersecting, but actually not. If you zoom in far enough, you realize, like a microscope, you zoom in far enough, you realize that, oh, they don't intersect. So the magic value is k equal to 2, radius 2. Is that clear?
Yep.
Okay, can you have equal to 2? Can you have more than 2?
Cannot.
Equal to 2 will cut how many times?
1 time.
More than 2?
2 times.
2 times, yes. Okay, actually, no, that's not true. If you zoom in far enough, we press the home button. Here is 2 times when it's k equal to 3, but if you change it to 30, okay, that's a bit big. You'll cut actually how many times? 4 times. Sometimes it may even be 3 times. If I can just change it down to such that it becomes tangential. You can imagine, right? This will be tangential at this point here, the turning point.
Yeah.
Maybe. So there'll be 3 points of intersection. If you increase it a bit more, now it's 4 points of intersection. But the main point is, when is there no solution? So it means that your k should be less than 2, strictly less than 2. Is that clear? Strictly less than 2. Can I hope this demonstration was clear enough.
Yeah.
All right, 2.5 cannot, must shrink down. 2 touch 1 time. When it's exactly 2, it touches 1 time, still not allowed. So you must go smaller than 2, smaller than 2. But you must be bigger than, radius must be bigger than, length must be bigger than. Length, can you have negative length?
Cannot.
Cannot. So maybe can be 0 if it's no length at all. But if you want the circle to exist, then your 0
more
should
than 0.
Or more than or equal to 0. Yeah, more than 0. Sorry. Yes, if you want the circle to exist. Okay, now go back to the iPad screen. Hopefully you can actually visualize that from graph sketch without using a GC, without using technology. But I mean, during exam conditions, a bit difficult, right? So I guess you have to get used to it. So what was I trying to show you? I was trying to show you, yeah, sorry, I wanted to show the solution, sorry, over here. Okay, so for the equation to have no real roots, you need the 0 less than k less than 0 less than k means k more than 0, because it's a radius, right? You want the radius to be positive length, so more than 0. But you write it as 0 less than k, and k must be less than 2. Because if it's equal to 2, you'll touch 1 time, more than 2, you'll touch more than 1 time, which we don't want that. We want 0 points of intersections. So 0 less than k less than 2. Is it clear?
Yeah.
I hope it was convincing with the Desmos demonstration. back
Yeah.
to the iPad screen. Okay, good. Yeah, next one, question 9. Here I'm not sure what's going on, why you duplicate. And here your equation also wrong. Because if you see, this so far is correct, but when you want to find the what do you call that? The asymptotes, right? You have to pretend the right hand side equals 0. So x squared over 16 minus y squared over, how come it become a 1? Oh, right, cancel off. Okay, over 1 equals to 0. Then solve for y. So y squared equals to x squared over 16. Y equals to plus minus square root x squared over 16, which is plus minus x over 4, right? It's not 16, it's 4, square root of 16.
Yeah.
Maybe I write it as a fraction in case you're confused. X squared over 16, which I show a bit more working. Square root x squared over square root 16, which happens to be plus minus square root x squared. We'll cancel each other. You get left with x. Square root 16 is a 4. So that's why the asymptote is wrong. Should be a 4, not 16. Clear? Clear?
Yep.
Okay, can. Now, next one. This is still under question 9. What did they ask? You got two curves, x equal a sine theta plus 4, y equal a cos theta. The trick here is you're supposed to use sine square theta plus cosine square theta equal to 1 instead of sine 2 theta equals to 2 sine theta cos theta. That is true. What you just did was true. This part is true, but it's not useful because when we try to find Cartesian equation, we are trying to eliminate which letter? The a, the x, the y, or the theta? The theta. Here still got theta. How to solve? You can't really solve it, right?
Yeah.
When it's 2 theta. So a bit difficult. Not impossible, it's just a bit difficult. Maybe you could work with y equals to a cos theta, and then you draw a picture like the following. Here's a 90-degree triangle. 90-degree isosceles triangle like this. Let's split it in half. You can call this to be theta. Okay, wait, that's not really correct. Let me try again. Okay, let's say that you have a right angle triangle like this. If this is theta, we know that y over a equals to cosine theta. So cosine theta is y over a, so adjacent over hypotenuse. That means this guy must be a square minus y square, right? Now, if we have 2 theta, what happens? It means that we need to draw a copy of this guy. And then we have another theta here, which means that we now have 2 theta. Can you see? 2 theta. Maybe it's not 90. It's not 90. It's not 90. All right. Then what was our objective? We want cosine. We want the sine of 2 theta, right?
Yeah.
So what rule do you think we can use? Oh, by the way, here is positive square root a square minus y square. So at the bottom, by symmetry, it must also be square root a square minus y square. So altogether, this is 2 times square root a square minus y square. Okay, I'm trying to go along with your argument and show you that your argument will still work, but it requires this elaborate drawing. And it still works. I'm just going to demonstrate. So now you got 2 theta over here. That means that if you want sine 2 theta, what rule do you think you want to use?
Sine rule.
Sine rule, exactly. Did you think of using sine rule? No, right?
No.
So your method, it will work, but you need sine rule. Very complicated. Not recommended. I just show you that it works. Sine 2 theta here, opposite length is 2 root a minus square root a square minus y square. And then you need another angle and another, what you call it? Another length. So by symmetry, here is a, right? So this guy is also a, correct?
Yeah.
Can I just clean up the diagram a bit because it's getting a bit messy? I'm just going to label a 2 theta. Can?
Yeah.
Okay. Yeah, that length, that bottom length there is y. I will just highlight it. Now, we can find this angle. Let's just call it alpha. Okay. Now, sine alpha will be opposite of a, right? Now, if you look carefully, this is right angle triangle. So that means that what is sine of alpha? Opposite over hypotenuse, right? And you can see opposite over hypotenuse is y over a. Correct or not?
Yeah.
Right. What I'm trying to do here is I'm ignoring this line. What I did before when I'm getting this equation is I'm looking at this triangle here, and then I use sine rule. Okay, it's just a coincidence that it looks like 90 degrees. It's just a coincidence. Right, this pair and this pair. Clear so far?
Yeah.
Then after that, sine alpha is because there was the right angled triangle here, which means sine alpha, I can focus on this right angled triangle. Opposite over hypotenuse means this guy is y over the hypotenuse a. So it means we have y over a divided by a. Simplify, we actually get y over a square equals to sine 2 theta divided by 2 root a square minus y square. Clear so far?
Yeah.
Then you can solve for sine 2 theta. That will give you y over a square. Can you replicate this during exam?
No.
This is non-standard strategy. So it will work. It will work. Can. You see, it's now in terms of y. So we have successfully eliminated theta. But that is not recommended. Too long-winded. Strongly recommend you to use sine square theta plus cosine square theta equal to 1 instead. Because you can make cosine theta and sine theta a subject. You just need to bracket, square, add them together equal to 1. Okay?
Okay.
Yeah, then eventually you'll get simplify it into a equation of asymptote. The a's will cancel away. Is that okay? Let me, because the working never show the how to do it. I'm just gonna demonstrate here. So what I mean is, y over a square is cosine square. You add on to sine square, which is x over a minus 4 bracket square. This is equal to 1. Simplify, you get y square over a square. Simplify, you get, wow, this is complicated. X square over a square minus 2 times x over a times 4. So it's 2 times 4 is 8. Add on 4 square, which is 16, equal to 1. Is that okay?
Yeah.
Now, that is actually for the second part of the question, right? So, yeah, did I do something wrongly? Let me see. Okay, maybe I should not have expanded that x square minus a square. Here's what you could do instead. Here's what we could do. We can multiply throughout by a square. So you get y square plus x square minus 8ax plus 16a square equals to a square. And what happens next is something. Let me see. Oh, this is a bit difficult to factorize. Let me see. Bit complicated. Let me see. This should simplify down into x minus 4 bracket square plus y square equal to a square. But if you bring the 16a square over, there'll be a problem. Let me see if you copy down the equation correctly. Right. Sorry, that was a mistake. This is wrong. You cannot. I trusted you're working. Oh no. This is wrong. Why is it wrong? X equals to a sine theta plus 4. If you bring the 4 over, you get x minus 4, right? Change to a minus sign. But what happens when you got a times sign? You have to divide by a, right? The entire thing must be divided by a. Okay, so it should actually be x minus 4 over a. Right? Correct? Not x over 4, x over a minus 4. You're missing out over a here.
Oh, yeah.
Right? Should have a divide by a. So yeah, that's why it's wrong. That's why I also got error carried forward. Let me restart. Oh my, it is 113. Okay, let me just quickly factorize this. So okay, I realized that the solution already showed you how to do it. So what they did was they left it as x minus 4 equal to a sine theta because they are allergic to fractions. Most people are bad at fractions, so we avoid fractions as much as we can. So you get this guy, we call it equation 1, equation 2, we square each of them, 1 square plus 2 square. So we end up with x minus 4 bracket square, which is, plus y square, which is a square sine square plus a square cos square. Anything special about the right hand side? Yes, you can factor out the a square, which gives you sine square theta plus cosine square theta. But wait, what's sine square theta plus cosine square theta? Correct, very
1.
good. It is 1. Then you times 1, you're left with a squared. Then therefore you have a 1x squared, 1y squared equals to some constant. If you just divide by a squared, you get back to 1, you'll get the equation of a circle, right? I mean, actually, this is the equation of a circle already. What am I talking about? This is a circle. Circle such that the center is 4, 0, and the radius is equal to a. Is that okay?
Yeah.
So that means that in order for you to have a circle of that center at 4, 0, radius a, look back at your diagram. This is the original graph. Then now you're trying to draw a circle center at 4, 0, which is over here. And then you have radius a. Can you visualize what's going on? All these are possible circles with different radius. Now the question is asking you for what? The question is asking you to find the range of values of a such that C1 intersects C at 4 distinct points. Which one works? Let me draw in a few circles. This one, this one, this one. So bad. Let me try again. This one or this one. Which one will intersect 4 times?
The second
Option
one.
1, 2, or 3?
2.
2. This is tangential, and it cuts the curve 2 times. So how many points of intersection?
Oh,
There's only
the third
one.
one.
Exactly, it should be a third one. You see this one only cut 3 times, right? So it should be slightly bigger than the option 2, which is option 3. Okay, you'll cut. Of course, sorry. I think you're confused by the graph. It doesn't stop here. The graph actually goes all the way. So it does actually intersect here, 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 and here 4 times. Okay.
Oh.
Do you understand the idea? The graph keeps going forever.
Yeah, I only
just that you-
realized just now.
Okay. Yeah, then you'll get the 4 point of intersection. So basically, what you realize is that this is the boundary case when it's equation of a circle at point 2. What's the radius over here? -4 to 4. Length is 8. When it's radius 8, it only cuts 3 times. So that's not good enough. We need it slightly bigger than this circle too. So it must be a radius that's bigger than
8.
exactly radius bigger than 8. In terms of algebra, that will be a is bigger than 8. Is it clear? Because radius is a.
Yeah.
Can Yeah. So that's how you answer the question. Interesting question. You must really know your graphing techniques in order to solve this. Like really, really clear. Like a should be bigger than 8 in order for you to cut 3 times. Sorry, not 3 times, 4 times. Cut 4 times. C is the circle, C1 is the hyperbola. Cut circle, cuts hyperbola 4 times. Radius must be more than 8. A is more than 8. Clear?
Yeah.
Yeah, okay, good. So, oh, right, there's actually one more hidden question. Sorry, I forgot to answer. Find the range of values of m such that there is no intersection between the line y equal to mx and c. Okay, so what you need to understand is, let me do a Desmos demonstration now. Let me reset the graph. What were we trying to draw the graph of? We are trying to draw the graph of x squared minus 16 y squared equal to 16. I mean that's a C1. Is it C1 or C? I can't remember the subscripts. But anyways, doesn't matter. Equal to 16. This is your hyperbola. Can you see the hyperbola?
Yeah.
Can Now we want y equal mx. So here's the mx. You can play around with your slider because this is Desmos. Can you see what's going on when you change the m? When it's negative 1.4, y equal negative 1.4x. Negative slope. When it's 0, it's y equal to 0x, which is y equal to 0, horizontal line x-axis. Then when you tilt it, when you increase the gradient, you tilt it a bit. Can see or not?
Yeah.
Okay, clear. So what is the question? The question is asking you, find the range of values of m such that there is no intersection. Can you see that when the equation of the asymptote that we found was 1 over 4x. 1 over 4 is 0.25. So let me just key in. So can you see that if I just zoom out a bit, the asymptote, the y equals to 0.25x is the asymptote. Can you see? So it never touches the graph, right? The black and the red never intersect.
Yeah.
Can see or not? Can asymptote, that's the idea of asymptote. You just keep going further and further. You think it intersect, but no, there's always a tiny little gap between them. There's always a tiny little gap between them. So of course, the other equation, maybe I should just key in 0.25x and y equals to negative 0.25x. The asymptotes we found 1/4 is negative, is 0.25. In order for you to not intersect, you need 0.25. But in order for you to intersect, you need to just tilt it a bit more. What if it's 0.26? What happens? Oh wait, if it's 0.26, does it intersect? Okay, you see, green color is 0.25x. Here I tilt it to 0.26, the red one. Can you see the red one?
Yeah.
You tilt it a bit to the left. Does it intersect or not?
No.
Doesn't intersect. So that means find a range of values of m such as there's no intersection. You can have a value of m that is bigger than 0.25, right? Bigger and bigger and bigger all the way until it becomes like positive infinity. But you can also have the other case. What if it's negative 0.25 and you made it slightly smaller, so negative 0.26? Does it intersect? What if you make it even smaller? Does it intersect?
No.
No. So that's the answer. What's the maximum you can go? Is until negative infinity. Okay, so your answer is very simple. You just need to identify your asymptote and then you just make it a bit more negative or a bit more positive. So that's why the answer is less than negative 0.25 or more than positive 0.25. Is it clear?
Yeah.
Okay, that's what they have over here. Less than negative 0.25 or more than 0.25. 1/4 is 0.25. Oh, they also included equal sign because when it's exactly equal, it is the asymptote. Okay. Is this clear?
Yeah.
And then okay. I think you need to go off already. I also need to go off. Yeah, so for question 11, last question. You just have to be careful. I'll just finish up this one. You can use the GC to help you to draw the graph. Oh, that's question 10. Ayo, no time to go through question 10. For question 11, this one is A-level question, so I guess it's important. The trick here is you just need to realize that this is A plus B times A minus B, right? So there's a formula you need to remember. It's A squared minus B squared. Okay, but you need to be a bit more tricky. You need to add the two equations so that you can eliminate the positive and the negative 1/t, like this. And you subtract, you also eliminate the t. And then after that, you get A plus B to be x plus y, A minus B to be x minus y. You multiply out, you get x squared minus y squared equal to 4, which is the equation of a parabola. Hyperbola. Okay? Is that okay?
Yeah.
Can yeah, so now from there, you can just draw the graph. That's all for this question 11. No time already, I have to call it a day. Question 10, we'll go through next lesson.
Okay.
Okay, that's all. Thank you.
Thank you.
I'll send you the bye-bye. I'll send you the homework later.
Okay. Thank you.